So, ang isa pang kagandahan na nakita ko sa Powerhouse, yung kanilang, pag nagturo sila by the heart, at talagang hindi nila kami pinababayaan. Isa pa sa nagustuhan kong serbisyo na ipinoprovide nila ay ang kanilang spoon feeding style sa pagtuturo. At mga review materials, maraming review materials na ipinoprovide sila sa amin, na doon maraming lumalabas sa board exam. At ang mga staff nila napaka-friendly, lalo na yung mga teacher.
Paano naging benepisya sa iyo at sa iyong pamilya ang pag-enroll sa NPHD Review Center?
So, simula nung nag-enroll ako, nabago yung buhay ko dyan sa Marina's Powerhouse. Dahil dyan, nagsimula ang aking pag-asenso sa buhay. At nagamit ko yung mga basic principle na natutunan ko sa Powerhouse. Lalo na yung mga itinuturo sa akin sa pagtutroubleshooting.
Sa ngayon, ano ang eksaktong position mo sa barko?
Sa ngayon, ang aking position ngayon sa barko ay isang electrotechnical officer na yung pinakamataas na rank sa ship electrician sa barko.
May plano ka rin ba mag-upgrade ng iyong skill mula sa pagiging registered master electrician to electrical engineer?
Actually, nakapagtapos na po ako ng BS Electrical Engineering, ITIAP, sa Manuel S. Enverga University. At sa ngayon, ongoing na po ako sa aking pagre-review sa Registered Electrical Engineer Board Exam this coming April 2022. Ako po si Virgilio Daniel Jr., dating security guard. Ngayon, isa ng Electro-Technical Officer. Kung gusto mo tutukan, mag-powerhouse ka na!
Ako'y naririto sa aking trabaho, nag-review sa Powerhouse. Tagumpay ay dala ko, pagpapakumbaba ay natutunan ko. Kahit marami ang tawag sa akin ay amo, ngayon ay alam mo na kung saan dapat pumunta. O pare ko'y huwag tatanga-tanga kung gustong makuha pangarap na lisensya. Kung gusto mo tutukan, pag-powerhouse ka na.
Tutukan, tutukan.
Tutukan, tutukan.
Sa Powerhouse, tutukan.
Sa Powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Focus ang isipan.
Focus ang isipan.
Tutukan, tutukan.
Tutukan, tutukan.
Sa Powerhouse, tutukan.
Sa Powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Spoon feeding ang gagaan.
Nagtapos na ang 30 kababayan natin na nabiyayaan ng libreng short training course ng Aksyon ni Kuya. Nagbabalik po si Mon Hoxon.
Nagtapos na ang first batch ng mga kababayan nating sumailalim sa free training course na ipinagkaloob ng Aksyon ni Kuya Daniel Short Training Courses Program. Sila ang mga nag-aral ng kursong Building Electrician at Wiring Installation. Nagkakahalaga ng mahigit 6,000 piso ang kursong ito, ngunit libre itong ipinagkaloob sa pamamagitan ng Sophia Review Training and Consultancy. Ito ay bahagi ng public service ni Kuya Daniel na makapagbigay ng libreng edukasyon sa ating mga kababayan. Bukod sa libreng training, tutulungan din ng Sophia ang mga nagtapos na makakuha ng lisensya.
Matutulungan din po namin sila in terms of getting their license, PRC license po. Sa field po ng electrician po, ang highest license po na ma-achieve po nila, ito po tinatawag na Registered Master Electrician.
Ang mga lisensyang ito ay maaring magamit ng mga nagsipagtapos upang makapag-apply ng trabaho sa labas ng bansa o di kaya'y sa mga malalaking cruise ship.
Sa barko po, usually po ito po yung requirement. So maganda po ang opportunity rito pag may license sila. Ang mga full-fledged po na master electrician sa barko, ang sweldo po niyan ranging from 5,000 to 6,000 US dollar a month.
Ito si Lolo Arsenio, 66 na taong gulang. Sa kanyang katandaan, nais niyang samantalahin ang pagkakataon na matuto upang kahit papaano ay magkaroon ng pagkakakitaan.
Kung may pagkakataon na makapagtrabaho, magtatrabaho pa po.
Sa mga darating na buwan ay muling magbibigay ang Sophia ng libreng training sa ating mga kababayan. Mon Hoxon, UN TV News Worldwide.
Patuloy na nagkakaloob ng libreng short training courses ang UNTV katulong ang Sophia Training and Consultancy. Ang mga kursong ito ay maaaring magamit ng ating mga kababayan upang makapag-apply ng trabaho, hindi lamang sa Pilipinas kundi maging sa labas ng bansa. Ito ang balita ni Grace Casin.
Bilang bahagi ng public service ni Kuya Daniel na makapagbigay ng libreng edukasyon sa ating mga kababayan, nagbukas ng isang free training course ang Sophia Training and Consultancy, katulong ang UNTV para sa ating mga kababayan. Sa pamamagitan ng aksyon ni Kuya Free Short Training Courses Program, mayroon ng pagkakataon ng ating mga kababayan na sumailalim sa isang training kahit hindi sila nakapagtapos ng pag-aaral.
Actually, right after their graduation, we are referring them to we will refer them to our tie-up company. So namely, ito yung Beta Electric Corporation, LRT, MRT, at saka yung isang construction din, yung GTEC Development Corporation. So actually hindi lang yung training nila namin sila i-guide hanggang sa paghahanap nila ng trabaho.
Sa ngayon ay Building Wiring Installation Course ang libreng inaalok ng UNTV at Sofia. At sa malapit na hinaharap ay magbubukas pa ng maraming kurso na maaaring pasukan ng libre ang ating mga kababayan.
Basta marunong bumasa at sumulat. So no required educational attainment, no kahit anong edad mo, of all ages siya. So pwede rin actually kahit babae kung may gustong mag-training din.
Isa si Lolo Arsenio na sinamantala ang pagkakataon na matuto upang kahit papaano ay magkaroon ng pagkakakitaan.
Gusto ko kasing magkaroon ng income pa kahit na matanda na ako para maka-income nga ako. At rin ako sa mga bata pa, maengganyo sila na yung mga walang ginagawa. Makapag-aral din sila.
Bukod sa Sofia, nag-aalok din ng libreng training ang Pulinjoy Institute para sa ating mga kababayang nagnanais matuto ng healthcare, caregiving, housekeeping services, food and beverages services, at household services. Grace Casin, UNTV News, Worldwide.
Ang tubig ay hindi natin dapat naaaksaya, lalo na kung maiisip nating kahit tubig ulan lang ay napakahalaga na sa iba. Gaya sa mga naninirahan sa dako ng Bonje Town sa bansang Liberia. May alam man silang water pump, pahirapan naman ang pagpunta doon. Kaya si Nanay Oretha, naghihintay na lang sa pagdating ng ulan upang may magamit na tubig at maiinom.
I are sick. Oh, my body can be hurting. Yeah, and feed go tasting for water, I be coming. All of my food can be hurting. All my body can be hurting. So I say, when for me to rest, then I get rainwater.
Hindi na kasi niya kayang dumayo pa sa kabilang bayan at wala rin naman siyang mapakikisuyuang mag-igib para sa kanya.
So now I rainwater we can drink because they walking out to go for the water, I say, I'm not able. And I get nobody cheer you small. And I will go for water. So that the rainwater we can drink. Yeah.
Si Nanay Turney, naaawa namang iwan ang mga anak at hirap na ring mag-igib sa edad na 53 taong gulang.
No point around here. The place where I can move from, I go for the water, the distance is very far from me. I can see the children in here, they crying, I go for water. The distance is very far. And in my old age, I'm able. But still, I will try my best and go for the water because I walk close, I cook, I table. But what to do? You not go there, you not use water, but the distance is very far. Because in my old age, so I'm forced to be in the water.
30 minuto hanggang 1 oras na lakad kasi ang kailangan nilang gawin bago marating ang pinakamalapit na poso. Hindi nakakayanin ng mga may edad at may kapansanan.
I have to wait for water. I beg. Because no water, no way to wipe my face. See, no water, so no way to wipe my face. Because if I see, there are no one to do. I not seeing a blind. So I just beg it.
In the morning, say I wake up, I can pray for water. Want to be here. I can pray. I lay down in the evening, I can pray. In the morning, I get in ulcer, I can pray. In the day, say I sit down in my heart, I can be praying. For water, want to be here.
Sa tulong at awa ng Diyos, nabigyan ng tugon ang panalangin ng mga residente sa lugar. Sa pamamagitan ng Free Potable Water Project ng Members Church of God International, hindi na sila mahihirapang mag-igib at makakatikim na sila ng malinis at ligtas na inuming tubig. Bagay na lubos nilang ipinagpapasalamat sa Diyos.
For today, I thank God. Why I will not drink rainwater, I can pour now. In Church of God, I'm standing there. I will not drink rainwater now. So thanks be to God.
I thank you to God, so because water here now, I will not suffer, I will not care hard time for water again. I will not go far place for water. For first time, I used to go far place for water, to wash clothes, to cook the distance far. But thank you to God now, water here, I tell you, thank you. Plenty, I have it all.
Thank be to God. We tell God thank you for the church to give us safe drinking water in Punjab. Thank you.
Isa na namang komunidad ang ating napaglingkuran at nakakita ng katunayan ng kapangyarihan ng panalangin at pagtitiwala sa may kapal. Ang kanilang mga pagpapasalamat sa Panginoon ay sapat upang makapawi ng pagod nating magkakapatid. Dahil muli, isa na namang mission accomplished. Lumiwanag na gayon ang inyong ilaw sa harap ng mga tao upang makita nila ang inyong mabubuting gawa at kanilang luwalhatiin ang inyong Ama na nasa langit. Salamat sa Diyos sa buhay, lakas at pagkakataong maiparating sa iba ang dakilang pag-ibig niya saan mang panig ng mundo.
Sa social media matapos i-post ng netizen na si Lovely Soto ang pamimili ng mga grocery items without spending a peso, ha? Free store daw ang tawag dito na isang charity campaign na pinamunuan ng Members Church of God International o MCGI. Ang mga nandito, mga food necessities kagaya ng bigas, kape, may instant noodles, canned goods, at marami pang iba ang makikita po dito sa free store. Nang simulan ang proyektong ito noong Marso para lamang ito sa mga miyembro ng kanilang sekta. Pero dahil sa tuloy-tuloy ang pagdating ng supply sa mga free, ayun, binuksan na rin ito sa publiko. Kaugnay po niyan, makakausap po natin Brother Danny Navales, miyembro po ng Church of God, pasensya na po, brother, members of the Church of God International o MGCI. Brother Danny, magandang umaga po sa inyo.
Magandang umaga po, Ma'am Bernadette. At magandang umaga po sa mga taga-subaybay ng inyong malawak na palatuntunan.
Kala ko ho, broadcaster kayo, yung setup natin, pang teleradyo Taon po ko doon.
Hindi naman po.
Ang ganda po ng setup nyo, Brother Danny, pero mas maganda po yung ikakwento nyo sa amin. Free store. Okay. Paano nyo nagawa itong gawing libre? Paano po ba ito nagsimula?
Yes, ma'am. Ito po yung nagsimula sa isang advokasya po na tinataguyod po ng Church of God International maybe parang decades ago na kung saan ang kapatiran po ng Church of God International ay talagang nililingap natin yung mga kapatid natin na mga walang anuman at dahil doon nabuo po ni Brother Eli Soriano at ni Kuya Daniel Rason ang ganitong sistema sa mga members ng aming church dati. Pero dumating nga po itong malaking pagsubok na ito, ang pandemic, ay naisipan po ng ating Kuya Daniel na ito ay ibahagi sa publiko dahil nakikita naman natin na napakaraming mga nangangailangan na sa maliit na paraan makatulong tayo at huwag na tayong makadagdag sa problema ng ating gobyerno. At ito po ay nag-udyok o nag-umpisa sa isang pagkilala, siyempre sa aral ng Diyos na nakasulat sa Bible na gumawa tayo ng mabuti sa lahat, ibigin ng ating kapwa-tao sa pamamagitan ng kahit anumang mayroon ka. Gaya ng sinabi sa Bible doon sa Luke 3:11 na yung mayroon namang 2 tunika ang wika, magbahagi naman sa wala at yung may pagkain, gayon din naman ang gawin. Dahil po dyan, ay binalangkas po, kinonceptualize ni Kuya Daniel Razon ang programang ito sa mas malawak na scope. In fact, Ma'am Bernadette, ito po ay sabayan nating ginawa, inilunsad last week, worldwide na po ito.
Wow! Saan po nakukuha yung, galing po sa simbahan, yung donation na grocery items?
Yes, ma'am. Opo. Purely, ito po ay kontribusyon ng lahat ng mga faithful, mga kapatid, at wala itong tinatanggap tayong tulong na anuman sa non-members. Sila naman po kasi ang nagkukusa, yung natuto sila noong kamalayan na mas malalim na hindi natin dapat sa ganitong panahon pairalin yung spirit of possession, kundi yung spirit of giving and sharing.
Ganda. Ang ganda po. Tapos, papaano po pwedeng makabili? Kasi alam naman natin, libre. Masarap bumili dyan sa grocery na ito. Saan po ba yan matatagpuan?
Kung papaano po makaka-avail, ito po ang ating ginawa. Atin po itong baga inilapit, idunlog sa ating LGU para sa mas maayos na kaparaanan. Kaya sila po ang naging kapartner po natin at sila ang nagdidistingue kung sino ang magiging beneficiary ng free store na ito sa kanilang mga barabarangay. Nagbibigay po tayo ng stab at sila na po yung nagmamahagi nito sa kanilang constituents, ma'am.
Alam nyo, parang naisip ko po, parang yung ginawa ninyo, parang relief, pero parang na-innovate ninyo kasi sila ang mamimili ng kailangan nila. No?
Yes, ma'am. Yes, ma'am.
Instead, ang cute nung naisip po ninyo, naisip ko lang. Kasi marami po naman ang sa awa ng Diyos nagagawa ng relief work. And normally po, naka-plastic na yan. Merong sanitary, may hygiene kit, may pagkain, may bigas. Pero in this case, isang area ito, samot-sani ang makikita. Tapos pupunta sila doon and I suppose, tama po ba, Brother Danny, na parang kukunin nila yung kailangan lang nila tapos parang may budget sila pagpasok doon sa tindahan.
Yes, ma'am. Tama po yun, ma'am Bernadette. Dahil po, meron din naman tayong tinitignan na isang aspeto pa sa likod nito na hindi lamang ang ating mga kababayang Pilipino ay mabigyan natin ng ayuda sabi nga po ni Kuya Daniel, hindi naman sasapat yun, even in a week, ay hindi naman sasapat yun. Pero meron tayong tinitignan na ang ating kababayang kapos ay matuto din namang magprepara o maghanda para sa kinabukasan. Kaya yung pong ating munting binuksang ito ng mga free store, MCGI Free Store, ay meron tayong slogan na pinapaliwanag sa mga tao na get what you need but not what you want. Hindi po kasi dapat nating mapanatili yung parang akin ito, kinuha natin, hindi naman pala natin kakailanganin. Kaya ang tao mag-iisip ng ano ba yung kailangan ko for this day para naman yung iba ay mabigyan din naman.
Alam mo, ang talino po ng ginawa ninyo because it addresses the need of a person based on what they need and not what we want to give them, di ba?
Yes,
baka
ma'am.
magbibigay tayong hygiene kit, ang dami na nga pala nilang tabot, mga timba. So, maganda. Tama po yung naisip ninyo actually. Maganda po yung naisip ninyo. At least isang area kung saan sila ang pipili ng kailangan nila. May budget lamang, di ba? And at the same time, sila mismo ang nagtitimbang ano nga ba ang kailangan ko.
Yes, ma'am.
Wow, wonderful. At sana ho, Brother Danny, sana marami rin naman ang gumaya dito sa magandang example po ninyo. Of course, ang pinakamagandang example na ipinakita ninyo ay generosity at syempre pagtalima din, pagsunod dahil nga ito po ang utos sa atin ng ating Panginoon.
Opo, ma'am. Yun
Love
po ang
your
ating
neighbor. Brother Danny, thank you very much po. Regards po kina brother, ano bang tawag? Brother Pastor, ano bang pasensya na ako? Kina Sir Daniel.
Brother lang po. Okay na po yun.
Maraming salamat po kina Brother Daniel at syempre sa mga kasama po ninyo sa inyong simbahan. Thank you very much.
Thank you very much, Mama Bernadette. Kami po'y tagahanga ninyong matagal na at kami po'y nagpapasalamat. We're very grateful po na nabibigyan nyo kami ng malaking tulong na po ito na maipaliwanag natin sa ating mga kababayan na sa mga panahong ganito, hindi natin kailangan mag-away-away, magpuntos-puntusan, magsiraan, kundi mag-unite tayo sa pamamagitan ng pagkakapit-bisig at pagbibigay sa mga nangangailangan. Ang tinitignan po natin dito, Ma'am Badet, ay yun pong nasa likod na ang layon talaga natin dito ay gayahin. Yung iba kasi pag ginaya, para bang, uy, pinatent namin to, di nyo pwedeng gayahin. Talagang aming layon po, gayahin ito, opo. Gayahin ng ating mas marami pang magagawa. Dahil yun naman po ang iniwan na halimbawa ng Panginoong Jesus, nang siya'y gumawa ng mabuti, iniwanan po ang wika kayo ng halimbawa para magsisunod kayo sa mga hakbang niya. Yun po natulad sa 2:21 ng 1 Peter. Kaya, thank you so much, ma'am, sa inyo pong...
Dami ko natutunan sa inyo. Thank you very much po.
Share lang po namin, ma'am, of course, sa DCMM. We are very grateful po sa inyong broadcast na ito at naipapaliwanag po namin. At kalinsabay po nito, ma'am, kung mamarapati nyo po ang aming pagpapasalamat din sa lahat ng LGU na kung saan ay sumusuporta po. At kung meron po kaming nagagawang parang sa tingin nyo yung pagkukulang, inaamin natin na talagang hindi naman natin mapiperfect, pero deep inside sa awat tulong ng Diyos, umasa po ang ating publiko na itutuloy po ng MCG, ayon ng Church of God International, ang ganitong advokasya hanggat may nangangailangan at hanggat kaya pa po nating isustain. Yun po ang bili ni Brother Eli at ni Kuya Daniel naman. So with this, kami po ay hindi matapos ang pagpapasalamat sa inyong kabutihan na makapagpaliwanag kami ng konti at pagpalain naman po kayo at ingatan din naman sa ganitong pandemic sa lahat ng pagkakataon. To God be the glory po, ang aming layon, purihin ng mga tao ang Diyos na ating
Yes. Salamat po, Brother Danny, thank you. At sana nga sa kabutihang ating ginagawa, sana ho makita ang kabutihan ng Panginoon at pagmamalasakit, pagmamahal ng Panginoon. Maraming salamat, Brother Danny. Thank you very much for
Thank you so
inspiring
much,
us this
ma'am.
morning. Gayahin natin, kung gusto natin gayahin, any good deed, panalo to story dito po sa ating programa. Madami tayong matututunan. Pwede natin gawin sa ating mga lugar. Ano? Oo, dapat ginagaya ang kabutihan, mga kapamilya. Oras po natin ay 11:27.
are one in IIE mission and vision, instilling excellence in electrical profession, having a dynamic professional association, making innovative contribution to our nation. IIE members work stronger than chain and bolt, rising to any challenge involving watts, ohms and volts, BEREE and RME, connecting industries by the electric circuits. Join us together, IIE. Join us forever, IIE. With power cords cannot be broken. Join us together, IIE. Join us together, IIE. Join us forever, IIE. Synchronize our hearts to reach greater heights and brighter lights. We serve humanity with the power of electricity, making rigid transmission great for reliability, ensuring little power loss and high efficiency. From shifting from one place, the use of all energy. Join us together, IIE. Join us forever, IIE. With power cords cannot be broken. Join us together, IIE. Join us together, IIE. Join us forever, IIE. Synchronize our hearts to reach greater heights and brighter lights. There's only one institute, no one else can substitute. There's only one
Connection. Our speaker mentor for today is a graduate of Bachelor of Science in Electrical Engineering, batch 1996 at University of the East, Caloocan. He earned units in Master of Science in Electrical Engineering, major in Power Systems at University of the Philippines, Diliman, and Master in Construction Management at University of the East, Manila. Former cadet engineer, In-Phase Industrial Construct, former project engineer, Security Bank Corporation, former electrical consultant, Brown Bauhaus Architecture Studio, former training consultant, Meralco, former training director, PAMAV Training Institute, former CPE lecturer, IIEE, WESM, PAMAVTech, former electrical engineering regular faculty member, UE Caloocan, also former electrical engineering faculty member reviewer, Mapua Institute of Technology, Pamantasan ng Lungsod ng Maynila, Adamson University, Rizal Technological University, Technological Institute of the Philippines, Manila and Quezon City Campus, Perpetual University, Las Piñas and Molino, Cavite, Technological University of the Philippines, Taguig Campus, and Pamantasan ng Lungsod ng Valenzuela. He is a registered electrical engineer and a registered master plumber. Ladies and gentlemen, the president of Marinay's Powerhouse Team Review Center, let us all welcome Engineer Reginaldo Kuya Reg Marinay.
Okay, good afternoon everyone. Magandang hapon po sa inyong lahat mga kawerpa. Welcome to MPHT Review and Training Center. We welcome you to our free webinar on energy saving through power factor correction. So this is an English version. No? We want to cater our students from other countries. No? Although we are from the Philippines, majority of our participants are Filipinos, no? And we believe that Filipino students and practitioners can also understand the English language. We better speak English language so that other students from other countries will be benefited from this free webinar. And we welcome you, everyone. Okay, before we start, we request everybody to settle down properly, please. Okay, umayos na po tayo lahat, mga kawerpa. Please open your camera as our requirement for this webinar. If you do not open your camera, you will be removed in our Zoom class. Okay, is my audio clear to everybody? Is it clear? Okay, just thumbs up. Okay. So we decided to have some lectures in English version so that we can also help not only Filipino students and practitioners but also whatever nationality, as long as you understand the English language. And we apologize, no, because I'm not that well versed in speaking the language, so pagpasensyahan nyo na, no? We just want to help our students all over the globe as possible, no? Because there are some students attending our free webinar last week. We have Malaysian, right? Malaysian, and before that we have some Indian students, no? Indian students and practitioners really love electrical engineering. I remember one of the best movie I watched what's that? The three idiots. That's from India. It's an engineering film. No? So Indian really loves engineering. No? They really loves technology. So if there are, and maybe some someday there are some Indian nationals, no? I have read some comments from some Indian nationals, no, regarding our lecture. Sir, do you have topic, no? I can understand your language, no? Is that in Spanish? Sabi niya, no? So how I wish that you have a topic which is in English. So okay, so that is wish granted. So we'll try our best, no? Although we just have a packet of English, no? We don't have a much and a full English in our brain, no? So please bear with us. No? We just have a basic English. No? Alam niyo naman, pagka engineer, mahina daw sa English. Magaling naman sa math, ano, sabi nila. Okay. But from time to time I will also speak some Filipino language or Tagalog language so that to give more emphasis to our Filipino students, no? But our base language, no, it will be in English so that everybody will understand. That's our point, no? That's why there is a parenthesis in this topic when we posted this advertisement in our Facebook page. So there is a word there, English version. Although we already conducted this topic in we call this in Filipino the Taglish. No? It's a combination of Tagalog and English. But this time, I may say this is 90% or more than 90% in English so that we can serve, no? All students, no? As long as they understand the English language. So we welcome everybody. And we are also live in our YouTube live, right, partner? Okay, so we welcome everybody and also to our Facebook Live, we welcome, okay? So in the Philippines, so we call that as kawerpa, no? Our students and practitioners, no? Kawerpa meaning, if you heard that word from me, so it means brothers in profession. We are your brothers and sisters in electrical profession. It we mean kawerpa. Okay, so baka maririnig nyo sa akin yung salitang kawerpa. Usong-uso ngayon yung mga kana yan. Okay, so okay, let's settle down everybody. Sana'y maayos na po tayo sa ating pong mga lugar. Pakiayos po. Please open your camera. Please see to it that we can see your full face. Please open your camera. You will be removed. You will not open your camera 15 minutes from now. No? So, orasan po namin kayo. No? We are sorry if you do not open your camera, you will be removed in our free webinar. You can just watch us in the Facebook Live, but will not have your e-certificate. No? So it's better to be in the Zoom class, no, or in the Zoom meeting so that you will get your free e-certificate. Okay, so please settle down everybody. Are we ready to listen? Please thumbs up, mga kawerpa. Okay, handa na ba tayo? Are we ready? Okay, so pagpasensyahan nyo na po kung layon lang po na talaga namin na makatulong, no? Dahil ito'y libre naman po, wala po kaming sisingilin po sa inyo. Layon lamang po namin na makatulong po sa lahat, hindi lang sa mga Filipino students and practitioners, no, in our field in electrical, no? So, and those students and practitioners who are watching us, no, please bear with us if I'll be speaking a little of our language in Filipino or in Tagalog. Just ignore those things, okay? So that is just a spice on our communication, a way of communication. So it's just a spice. But we will assure you, we try our best for you to understand the lesson or the lecture for today. Okay? So we are on live, no, for this topic. But before that, we'll have first our pre-review lesson before we start. No? So this is just around more or less 45 minutes. No? So then after this, we'll have our live lecture. Okay? So we'll have our live lecture, and if there will be an extra time, so we can have a chance to have a question and answer portion. Okay. So shout out sa mga taga-Sanya, NBSU. What's NBSU? So shout out sa ating mga estudyante, no? So once again, this is Engineer Reggie, Kuya Reg Marinay. So magandang hapon. We are happy. We are really very happy to serve everybody, no? So though this is just a free webinar, but we are really happy to serve you. No? For me, it's a great honor to serve, no, all electrical engineering or technology or even electricians, no, our electrical students and practitioners. It's a great honor for me to serve everybody. Okay, so let's have first our lecture, no? So to our non-Filipino audience, please bear with us. Our pre-review lesson is in Taglish or is in Filipino. So, but there are some calculations. I believe you can also get this discussion. You can also understand, no? If you will listen carefully, no? Honestly, nowadays the Filipino language is not actually a pure a pure Filipino. From time to time, we are really using the English language. So, and I believe that you can also get something from here. So just give us around 45 minutes to show this pre-review lesson, and then right after this, we will have the pure discussion and the live discussion on the energy saving through power factor correction. Okay, so let us start now. And by the way, please, pahabol lang, no? Those students who has their full name in the Zoom name, please replace your Zoom name by your simply your nickname. It's a one-word nickname or any code name will do. Please do it right now. So do not put your full name in your Zoom name. Please rename. Please rename. Only one word so that it will be simplified so we can easily admit you once you disconnected in our Zoom class. Okay, so let us start now first with our pre-review lesson, and then right after this, we will have the pure English discussion of our topic. Sa Facebook Live, no? Okay, partner, no? Meron tayong mga viewers sa FB Live natin. So magandang araw po. Live po tayo ngayon, June 14, 2022. So you can call me Kuya Reg, no? So I'm Engineer Reggie and Marinay, or just simply Kuya Reg, no? Ayan, okay. So, punta po tayo, no? Punta po tayo sa question na pinadala ni Mr. Jubert Gaboa. Is he connected, partner? Connected ba siya, George? Ayun, nakita ko na siya. Okay. Sige, siguro mag 50-50 muna yan. Tawag dyan. Tawag dyan ganyan. Tawag dyan. Backline din, tawag dyan. Split screen. No? Ayan, okay. So, magandang araw sa iyo, Jubert. Yan, mukhang nasa trabaho si Jubert. Nasa trabaho ka ba ngayon, Jubert? Ayun, okay. Sige, maganda yan. Habang nasa trabaho, nag-aaral, di ba? Okay. So, ito, tama ba na itong tanong na ito ipinadala mo? Sa akin. Okay. So, sagutan na natin, ano? Okay, so the question, actually, may ilang tanong pinadala si Jubert sa atin. Ito yung unang tanong. Okay, sige, sagutan na natin. The first question, so the power factor cannot be less than blank and greater than blank. No? So ito power factor, hindi siya po pwedeng, cannot be less than, hindi siya po pwedeng mas mababa sa anong value at mas mataas sa anong value. No, hindi siya pwedeng mas mababa, hindi siya pwedeng mas mataas. Ibig sabihin, no, meron siyang certain range, no? So my answer here is letter D, 0 to 1. So di tapos agad, partner, ano? So pwede na 'yon, no? So, okay na ba 'yon, Hubert? Oh, kontento ka na doon? Walang paliwanag? Okay, yun nga po ang layon ng ating mentoring program. Ang layon po nito, hindi lang po basta sagutin po yung mga tanong, sagot, hindi po ganon. Ang layon po nito para mas ma-explore natin, mas ma-explain po natin, no, bakit yun ang sagot, no, as detailed as we can, no. So kumbaga detalyihin po natin yung ating kasagutan, ano. Okay, although sabi ko sa inyo from 0 to 1, no. So power factor cannot be less than 0. No? So ibig sabihin pala, wala palang power factor na negative. No? And greater than 1. Wala rin power factor na greater than 1. Bakit? Diba? So bakit? Okay, kasi po ang power factor, what is a power factor? Okay, so we have 3 triangles in AC circuits, no? In alternating current circuits. So meron po tayo 3 triangles. No? So meron po tayong theta. So this is our angle theta. This is what we call our power triangle, no? Unahin na po natin muna yung impedance triangle. This is our Z. This is a right triangle. 90 degrees, no? This is our R, this is our X. So, impedance, resistance, reactance. Okay? And then this is our power triangle. Apparent power, real power, reactive power. And then we have what we call the admittance triangle. Admittance triangle. This is admittance, this is conductance, this is susceptance. No? So, yung tinatawag na power factor, or simply PF. PF is professional P. Hindi. Power factor yan. Okay. Cosine theta. So, ibig sabihin, yung theta, yun pala yung angle ni R, resistance doon sa impedance. Ito pala yung angle ng real power doon sa apparent power. So, ito yung kilowatts mo, di ba? Ito, kilowatts to eh. Kilowatts. Ito naman yung kVA mo. No? Let's say, yung size ng transformer mo, naka-kVA yun. So, naka-kilowatts. Let's say, yung kilowatt load ng bahay mo o ng building mo. No? Ito naman yung tinatawag na kVAR. No? Or kilobar. No? Ano ba ibig sabihin ng bar? Sabihin ng bar, that is volt ampere reactive. No? Volt ampere reactive. Yan, volt ampere reactive. And then, itong admittance natin, no? Actually, yung admittance natin, yan yung reciprocal ng impedance. Kabaliktaran nito. No? Kaya ang symbol niyan, mo, ito kasi puro ohms lahat yan. Then yung G, conductance natin yon 1 over R, mo din yun. Then yung susceptance, that is 1 over X. Mo din po ang unit niyan. No? So, pag sinabi natin power factor, yan yung angle between R and C, P and S, G and Y. No? Conductance and admittance. No? So, sasabi natin na yung power factor, pag sisimula yan, yung angle theta, I mean, that is the power factor angle. Magsisimula po yan sa 0 degree. Kumbaga, 0 degree. Sabihin, kung ito yung S mo, ito P. Pwedeng magkaroon ng pagkakataon na yung P equal sa S, pagka 0 degree. No? Kasi yung formula ng P is equal to voltage times current multiplied by cosine theta o yung power factor. Yan. E sino ba yung voltage times current? Siya naman yung apparent power S times the power factor. So, P. So, kailan ba i-equal yung P sa S? Kapag ang power factor mo equal sa 1. No? Equal sa 1 yan. Okay? Unity power factor. No? Equal sa 1. Tingnan mo na. Paano ba magiging unity power factor? No? Kung ang power factor mo ay cosine 0 degree, that is simply equal to 1. Ibig sabihin ng 0 degree, so ito yung S mo, saan siya dito? Equal na siya sa P. 0 degree, nandito siya. Kumbaga, yung Z mo, equal na lang sa pure R yun. Habang tumataas yun, nagkakaroon siya ng reactive component. No? So, ganun siya. So, siyempre, by magnitude, wala naman negative angle. By magnitude dito sa nakikita mo. No? Wala naman negative angle. Magsisimula sa 0 degree, no? And then, pinakamalaki, 90 degrees. No? 90 degrees. Pero kaya lang, pagka naging 90 degrees, dito, hindi ka na magkakaroon ng top triangle mo, no? So, kumbaga, yung theta mo, wala ka ng 90 degree angle doon, no? So, ibig sabihin, kung pag 90 degree to, so, yun na yung pinaka-Z mo. Siya na yung X mo kasi. Kasi yung X, siya na yung 90 degrees. No? Yan, imaginary component. Siya yung naka-90 degrees. So, basically, yung theta mo, no, will be ranging from 0 degree up to 90 degrees. Actually, ayan. Or less than 90 degrees pa. No, yung iyong theta. No? Yung iyong theta. Ayun, may tanong dito. Power factor cannot be less than 0. So, yun nga. Kasi wala namang wala namang power factor na wala namang power factor na wala namang power factor cannot be less than, so wala namang angle na negative, no? Walang angle na negative. On this case, walang angle na negative, no? Okay? So, a greater than 1. Cosine 0 is 1. No? Cosine 0 is 1. Actually, yung angle theta mo is hindi naman sagad niya sa 90 degrees. Less than 90 degrees lang yan actually. Less than 90 degrees. No? So, ganun po yan. Okay, so wala tayong negative na value, no, sa power factor. Kasi nakadepende yan sa magnitude ng angle. Pag sinabing magnitude, yung value, yung sukat ng angle mo. No? So, wala yun. No? So, positive lang yun. Positive. Eh, sir, di ba merong negative angle? Oh, halimbawa, meron kang negative 30 degrees. Ano ba yung negative 30 degrees? Kasi di ba sinasabi sa trigonometry, pag ang angle mo, movement mo, nandito, say this is your voltage vector, 30 degrees to. So, positive 30 yan. E pag nandito naman, halimbawa, ito, kuryente mo to, that is your current I. Halimbawa to, negative 50 degrees. Ito naman, negative, pag ganyan. But for this case, we are talking of the triangle, the magnitude, yung sukat. No? Pagka-sukat, dimension, walang negative. Pagka-sukat. Yung negative na to, ibig sabihin na direction lang yan. Ibig sabihin ng angle mo, no? Sa trigonometry, pag sinabi natin positive angle, ang movement ng angle mo is counterclockwise. Yan. Pagka clockwise, that is your negative angle. Yan. So, ang angle mo, this is negative angle. No? Yan. Ito, negative. Clockwise. Pag ang angle mo nag-move ng counterclockwise, that is a positive angle. No? Kumbaga, yung yan, positive angle yan. No? Ito, negative angle. Yan. Kaya na sinabi ko, hindi siya pwedeng magkaroon ng negative value kasi nakadepende siya doon sa magnitude. So yung sukat ng angle mo. Magsisimula yon sa 0 degree. Sa 0 degree. And also the theta, madagdag natin. Yung theta natin, that is the phase difference between the voltage and current. Halimbawa, ganito. O ito, voltage mo to. That is your voltage waveform. Voltahe mo yan. No? Let's say, ito yung current waveform mo. Yan naman. So, our reference is the starting point. Ito yung simulang point. No? The distance between these two is angle theta. That is their distance. The distance between the two starting point of this waveform. No? So, there is no negative distance. In it? Is there a negative distance, Hubert? Or dimension or height? Or height? Diba? Yung negative na yun, that only signifies the direction. No? Yung negative. We are referring the angle here. We are referring to the dimension. Dimension. Like distance. Like height. Ano height mo, pare? Matangkat ako, pare. 6-footer ako. Negative 6-footer. Ano ibig sabihin ng negative 6-footer? Nakabaon sa lupa yun. No? Ganun ba yun, Hubert? Pag negative 6-footer ka, nakabaon ka sa lupa ng buhay. Ha? So wala namang ganun di ba? There's no such. So the angle here, we are referring to the positive value angle because we are referring to the dimension of this angle. Of the right triangle. No? Ano ang kanyang angle? Pero alam mo halimbawa, there's your meron negative angle. Alam mo, i-try mo to. Try mo to sa calculator. Cosine 30 degrees. Sige nga, try mo nga, Hubert, anong value niya? Tapos, i-try mo naman yung cosine negative 30 degrees. Yan. So, sa kanila, no? I-try lang natin. So, meron tayong cosine 30. Oops. Ano value natin? Yun, 0.866. Ito naman, cosine negative 30 degrees. Parehas lang. Hindi pa rin magbibigay ng negative cosine yan. Parehas lang 0.866. Nakuha mo ba yun, Hubert? Hindi siya magbibigay. Ibig sabihin, your cosine theta is equal to cosine of negative theta. No? So, ganun. No? Like, presume mo, halimbawa, may negative angle because of the direction. Alagay mo na nga. No? But never you can have a cosine theta that is negative. We are referring to less than 90 degree angle here. Okay? From 0 to less than 90 degrees. Doon tayo nagre-refer. Okay? Nakuha ba, Hubert? That is why, no? So, cosine 0, power factor mo, 1. Pinakamaliit na angle o walang angle, power factor mo, malaki. No? Pero pagka nilakihan mo ng konting angle, 30 degrees, naging 0.866. Ibig sabihin, Pag 0 degree, 1. Pagka 30 degrees, 0.866. Habang lumalaki yung angle, lumiliit yung power factor. Di ba, no? Habang lumalaki yung angle, lumiliit yung power factor. Okay? So, that is my answer to your question, Hubert. No? Okay, naintindihan ba ako ni Hubert? Hello, Hubert. Okay? So, basta tandaan natin ha, yung power factor angle, no? Siya din yung impedance angle, power angle, admittance angle, and the phase difference. Siya po yung phase difference between voltage and current. No? Siya po yun. No? Siya yung phase difference. Pag sinabing phase difference, yun po yung distansya. The distance between two starting point of the waveform. Okay? So, that is my answer to your question, Hubert. Okay, clear ba? Clear na ba sa'yo? Okay. Sige, salamat. Thank you.
Okay, good day everyone. Good day to our viewers in our Zoom class and also to our Facebook viewers. No? Live na live po tayo mga kawerpa. No? Anong date ngayon, partner? Today is November 15. No? Almost 1 p.m. na po mga kawerpa. No? Kami po'y kanina pa rin pong umaga dito, mga bandang 8:30 po. Kami po'y nagsimula ng magtanggap ng mga jo-join sa ating Zoom class. No? Then mga around 9, nagpasimula na po ang lecture po natin na ginaganap po natin dito sa ating free webinar. This is every Sunday po, no? Actually, 3 part po ito para sa mga late viewers po natin, no? Partner, tanggapin mo pa rin yung mga pumapasok, no? Okay, kaya lang wala na silang certificate kung mentoring lang yung kanilang aatenan, no? Okay, so we encourage everyone, no, to participate in our Zoom class. Mas maganda po sa Zoom po kayo sumama para meron kayong certificate na makukuha every Sunday. Okay? Again, this free webinar consists of electrical engineering video book. Okay? So, meaning we are going to discuss basic electrical engineering principles and concepts. The second part is the special topic. This is I consider this is an advanced topic, no? A seminar or webinar topic. Okay? Yung ating special topic. And then the third part is our mentoring program. So, this is 3-in-1. Tayo lang ang gumagawa nito, mga kawerpa, sa buong mundo. Sabihin na natin, no? So, wala pong gumagawang training center o review center na ganito, no? So, ito'y patuloy po namin gagawin ng libre para po sa inyong lahat, no? Okay, sige partner. Ready na tayo. Okay, so our first question sa atin pong tanong, no? Sir Alan, no? Kaalan, kawerpang Alan, ayan, ha? Bagong herdo pa yan. Okay, good morning po. Okay, so a common utilities tariff practice to penalize industrial consumer whose power factor falls below blank and give incentives for power factor above blank din. Ayan, ang tanong ni Sir Alan Tablada. Okay, huwag na muna natin tingnan yung mga choices. Actually, lumabas to pati sa REE, hindi lang sa RNE board. Pati sa REE, lumabas po itong tanong na to. Okay, makinig po ha, yung mga future REEs and RNEs natin. Okay? So, ito po muna ang aking explanation, no? Bago mong katanungan ni Sir. Kasi ang tanong niya, no, yung mga utility company, let's say, Meralco, no? Merong tariff practice yan to penalize consumer. Ito, pinapractice to sa Meralco, no? So, concern to sa power factor, no? Pwede kang makakuha ng incentive, no? Pwede ka rin makakuha ng penalty. Merong certain power factor para dyan. Actually, meron po akong separate pre-webinar, no? Tingnan nyo na lang po sa aking channel. Libre naman po ma-download yan. Patungkol po sa power factor correction. Doon ko po ine-explain yan. No? Pero, Sagutan na natin itong katanungan ni Sir Alan. Okay. Ni Ka-Alan. Okay, sige. Ito po ang aking explanation muna. Ka-Alan. Okay. Sabihin ng kapatid ha. Kawer pa. Okay, kawer pa nga Alan. Ito ang aking kasagutan. Ayoko pong sumagot. Pakita muna si Sir Alan. Iba yung nakikita natin yung mga facial reaction. No? Then, pakita rin natin siya sa Facebook, partner, para alam ng mga viewers natin na meron tayong live audience. No? Sa ating mga Facebook viewers, baka gusto nyo pong makijoin sa aming ginaganap na live, no? Mentoring. This is Tuesdays, Thursdays, 5 to 7 p.m. Then every Sunday, 12:30 to 2 p.m. naman po. Ayan. Okay. Pakita yung 50-50 natin. Na-disconnect si Sir Alan. Anyway, sige, ko-connect din yan. Maya-maya. Na-disconnect po Sir Alan kasi live na live. Okay, ito po ang aking paliwanag sa kanyang katanungan. Galing po ito, ayoko kasing sumagot partner sa sarili ko lang. No? Mas maganda may basihan tayo. Galing to sa Department of Energy, particularly the Philippine Distribution Code of the Philippines. No? O yun na nga, naulit pa. The PDC, Philippine Distribution Code. Okay, ano ang sabi ng Philippine Distribution Code? Sige, partner. Pakita natin. Okay, ang sabi niya, regarding, nasa Article 5.2.4, regarding the power factor. Sabi ng PDC natin, nada-download niyo po ito, nasa internet naman to, mga kawerpa. The user shall maintain a power factor of not less than 85% lagging. Huwag daw bababa. Ano ibig sabihin nun? Not less than. Minimum yon, no? Ganito yan. 85% power factor. Lagging. Not less than 85%. Patingin, partner. Yung nasusulat sa PDC. Okay? Should be not less than 85% at the connection point of the distribution system. The distributor shall correct feeder and substation feeder bus reactive power demand to a level that will economically reduce the technical loss. Kasi alam nyo, yung technical loss, isa yan sa component ng system loss na binabayaran natin sa mga utility company. No? Okay? Technical loss. Okay. The distributor may establish penalties and incentives. Ayun na. Okay? Like sa atin dito sa Metro Manila, meron tayong Meralco. No? Sila po ang nagpe-penalize at pwede rin silang magbigay ng discount. No? Power factor at the connection point. No? Based on the target level. Okay, for the case of Meralco, they are following that. No? Sinusunod nila yan, Philippine Distribution Code na yan. There is shall maintain not less than 85%. Here is the practice. Connected na ba si Sir Alan? Here is the practice. If you go less than 85%, you will get a penalty from Meralco. If you go higher than that, you will have a discount. Actually, wala pa tayong pinaka-detailed na lecture dito, no? Magkakaroon po tayo ng pinaka-detailed na lecture sa power factor correction, no? Sa December, partner. No? Pangako po namin sa inyo, libre pong webinar yan, no? Ipapasok natin ng Sunday yan, yung ating webinar, Energy Saving Through Power Factor Correction, wherein I will discuss this tariff, this computation sa electric bill. Meron po tayong lecture niyan, no? I-upload po namin yan, mga kawerpa. Pwede nyo pong i-download yan, libre lang, no? So, yung ating energy saving through power factor correction. This is just a general idea that I could give you because we have a limited time. So, If you go higher than 85%, especially if you buy capacitor bank, you connect, you will have discount in Meralco. If you go lower than 85%, because you're buying, let's say you are an industrial plant, you're buying a lot of motors, inductive load, I mean. You added electronic load, computers, no, lighting load, no, especially with ballast, no, inductive load. Say you have your fluorescent lamps. So these are inductive load. Okay. So if you are connecting inductive load, the power factor becomes lower and lower. But if you have capacitor banks, no, the power factor increases. Okay. Pag bumaba yung power factor natin sa 85%, may penalty tayo kay Meralco. Pag tumaas tayo ng 85%, nakakakuha tayo ng discount. Ganun po yan, mga kawerpa. May discount po tayo. No? Ano yung sinasabi dito, partner? No? May nakasulat dyan. The user shall maintain power factor not less than 85%. At, sabi, no? In the distribution system. Ano ba yung connection point, partner? O, basa. Pakita natin, partner. Next slide. O, galing pa rin po sa Philippine Distribution Code ito, ha? O, hindi ko po sariling hinuha ito, mga kawerpa, no? Tandaan po ninyo, pag ako po yung nagsalita, no, dito sa pinag-aaralan natin about electrical engineering or about electrical, I see to it na parati akong may basihan, no? Okay. Connection point, no? Hindi po tayo katulad ng iba na ano lang, na dinadaldal lang, no? Hindi po tayo ganon. As much as possible talaga, no? Meron po talaga tayong mga materials na kung saan natin pinulot yan, sa PEC ba yan, no? Sa NEC ba yan, distribution code ba yan, grid code ba yan, no? Kung ano man standard na pwede natin pagkuhanan, no? Sa inyong mga katanungan. Pag sinabing connection point, a point of connection of the user system or equipment to the distribution system. For users of the distribution system or to the grid. For users of the grid. Okay, doon muna tayo sa first statement na yung statement na the point of connection of the user system. Sino yung user system? Tayo yun. To the distribution system. Okay. Punta tayo muna sa basic na building, sa bahay, o sa isang building. What is that connection point? How do we analyze that connection point? Where is that? This connection point, let's say you have your transformer. Where is the last distribution system? It is found here. Actually, this is what we call the service drop conductor. Then, we have here the drip loop for the building. So, you will have here, of course, you will have your meter, right? This is actually the connection point. Ito po yung connection point, mga kawerpa. Yan po yung connection point natin. Sa Philippine Distribution Code yan, PDC, according to PDC. Pero, sa PEC, ano siya sa PEC? Siya yung service point, no? Okay? Philippine Electrical Code. Pwede naman po akong i-correct ng ating mga colleague, o ating mga kawerpang REE, o even PEE. You can put your comment below kung may mali po tayong na-share, no? I can't say to all of you that I'm teaching 100% correct. No? There is a possibility po na magkamali tayo, mga kawerpa, no? So, pwede po. No? Kung sa tingin nyo po, mali po ang ating pinapaliwanag po, pwede po kayong mag-comment below, magbigay po ng inyong saloobin kung mali po, no? Magbigay kayo ng data o even you can upload some pictures or drawings, no? So, kung meron po kayong correction sa aking mga sinasabi,
Ito naman po ay naka-Facebook naman. Tapos ilalagay pa natin sa YouTube, partner, no? Kung sa tingin po ng ating mga kawerpang lisensyadong REE and PEE, even PEE, no? Lalo mga PEE, mga sir, pwede nyo po akong i-correct, no? Kasi ako po hindi naman po ako PEE, no? REE po ang aking license, no? So, pwede po. Correct po ninyo ako mga sir, no? Ating mga PEE dyan, no? Okay. So, ito lamang po base sa aking research, no? Okay, pwede po tayong magkamali, ha? There is a possibility magkamali po tayo, ha? So, ayoko pong sabihin na for the entire program ng ating mentoring, lahat nung sagot ko doon, perfect, 100% tama. Ayoko pong sabihin ganon, no? O, pero siguro mga make it 90% partner, no? So, yun na lang po. Okay? Kumbaga, para sa sarili ko, ito yung tama, no? Ito yung tama. So, pwede po tayong i-correct, no? Of course, stand corrected, ika nga, no? Pwede naman tayong tumanggap ng pagkakamali natin, you know? Basta't mai-correct tayo kung sino man yung mga authority or yung mga ano. Let's have some healthy discussion. Maganda yon, no? Let us not treat ourselves as enemies, no? Hindi po gano'n ang aming ibig sabihin, no? So, hindi po. We are not competing to anyone. We are here to help the student to pass the board exam or to pass even the college exam, no? So, okay, tuloy tayo, ha? So, put your comment below, ha, if you have some correction. For me, this is the way I analyze this. This is the last distribution system here. Kasi kay Meralco ito eh. Sa utility itong service drop conductor. Ito service entrance conductor. Ito service drop conductor. According to PEC, yun ang tawag. No? Okay, I have a lot of lectures about building wiring. Nandoon lahat yon. You can download all my lectures in building wiring for free. Okay. So, wala na tayong kinita, partner. Ha? Puro libre na lahat. Dati may bayad yan, mga sir. Mga ka-wear pa. Okay. Hindi bale, marami pa tayong nakatago, partner, no? Okay. No, ilang porsyento lang po yung mga nai-upload namin dyan sa YouTube. No? Huwag naman isipin ng mga estudyante natin na lahat nai-upload na natin. No? Yan, nakita ko pala si Francis dito. Eh. Arang na. Hello, Francis! Arang na ba?
Hello po.
Francis, ha? So, hindi lahat nai-upload namin. No? Portion lang to. Portion lang. Patikim lang. No? Kumbaga, regalo na namin to sa ating mga ka-wear pa na mga nagre-review. Tuloy natin. Yung ating connection point, yun din po yung service point natin, mga ka-wear pa. So, tandaan natin yan. Siya din po yung ating service point, yung connection point. Yan. Okay. Sige, tuloy natin. Balikan natin. Connected na ba si Kaalan? Okay, Kaalan. Ka-wear pang Alan. Na-disconnect na naman, partner. Mahirap talaga pag live, no? Na-disconnect na naman. Okay. Andiyan ba siya? Wala. Mahirap batiin. Pag binabati mo, nawawala. Okay, anyway, papadala natin tong video na to sa kanya. Yun ang kagandahan po. Kung magbibigay kayo ng mga question dito sa ating mentoring program, no? Paano daw? How? Join kayo sa Zoom. No? Join kayo sa Zoom. Okay. Sige, sagutin na natin. Punta na tayo sa tanong ni Kawer Pangalan. O, Kaalan. Ito ang aking kasagutan sa tanong mo. Base sa aking eksplanasyon, ano ang sagot ko dyan? Anong letter? Okay. Basa. A common utilities tariff practice to penalize industrial consumer whose power factor falls below, ano sagot ko dyan? Falls below 85%. No? And give, sabi, no? And give incentives for power factor above 85% din. No? Kumbaga siya yung pinaka-base eh. No?
Kumbaga, minimum siya para hindi ka ma-penalize. Pero pag bumaba ka dyan, may penalty ka na. Pag tumaas ka dyan, may discount ka na. So therefore, anong letter ang sagot ko, partner? Letter C. Yan po, Kaalan, yan ang aking kasagutan, kawerpang Alan, sa iyong tanong, no? Yan. Ayun, connected na ulit. Di ko alam kung nasundan tayo ni Kaalan, napuputol siya. Anyway, papadala ko sa iyo yung video. Sige, padala na natin para may personal copy si Kaalan, no? Kaalan, papadala na namin sa iyo, ha? Yung video na to. Ang kasagutan ko dyan ay letter C. 85%. Ha? Yun ang sagot. Di ko natatanungin kung ano yung sagot ng reviewer na pinagkuhanan mo dyan. No? Hayaan mo na yan. Basta yan ang sagot ko. Letter C. Okay na ba? Kaalan, letter C. Yun ang aking kasagutan. Okay na? Okay ba yung audio mo? Pwede bang marinig dyan? Hello, Kaalan. Di kita marinig. Hello, Kaalan. Oo, Kaalan. Okay na. Okay na yung sagot ko sa'yo. Letter C. Thumbs up nga kung okay na. Baka meron kang reaction. Okay na tayo. Okay na. Okay na raw. Okay.
Okay, once again, good afternoon, everybody. So, do you hear me to our audience? So, please thumbs up if you hear my voice, please. Thumbs up na tayo dyan, mga kawerpa, kung tayo naririnig po ng maayos. Okay, magandang hapon. Okay, good afternoon, everybody. So, once again, so we have our topic to be discussed today. So, actually, we already conducted this topic in Filipino version, but today we'll try our best to discuss this in English so that our practitioners and students would understand our discussion for today. Although from time to time, I'll be speaking a bit of our Filipino language so that there will be some emphasis on in Filipino or Tagalog language, no, for the Filipino students. But our base language for today is in English, and I apologize. No, we apologize. We are not that well versed in using the language. No? We just want to help. We just have an intention of helping our students and practitioners so that they will have a little knowledge on this topic, and this will be uploaded to our YouTube channel. Okay, so let us start now our discussion. So our topic for today is about the energy saving through power factor correction. So what's this all about? So we just put, actually this topic is on the power factor correction. That's the word for this topic. No? That's the topic, the power factor correction. We just put this name, energy saving, because the number one purpose, the number one intention of power factor correction is for saving, to save energy costs. Okay, so once again, my name is Engineer Reynaldo N. Marina. I am the president and one of the owner of MPHT Review Center. Okay, there are some students sending their question. One of the question is it allowed by the utility company to have a power factor correction? Is it allowed? Sir, I remember I watched in the television, there is a commercial regarding the energy saver. So they will just put the about the size of a mouse, a little bigger than the size of a computer mouse. So they would plug in the outlet, and then it saves electricity. Is it true? Is it effective? Is it really true? Okay, so we'll be answering this question. No, is this allowed by the utility company? Is using these capacitor banks, no, really saves electricity? Is allowed by the utility company because we pay our bills in the utility company. So I will answer. Yes, it is allowed because the utility company itself, they are using power factor correction capacitors. No? If you are seeing this type of capacitor, no, just like this one, okay, you see this picture, okay? So this is being used in the distribution line. No? You will see this in the distribution pole. So in here, in this picture, so there is a capacitor, power factor correction capacitors here. Okay. So, and also this is being used in the commercial and industrial buildings. So we have here these capacitor banks. No? But sir, my question is, what about in the residential? There are so many energy saver products. No? So it says in the box of that product, it says that you can save electricity from 15% to 35%. No? I remember one of the our largest mall in the Philippines, the SM, the Shoe Mart. So they would sell this product. The salesman would tell you that this saves 15 to 35%, and they have their experiment, no, a sample circuit, and they will show this to you that this can save electricity. That can lower the current flowing. Okay, when they plug in this device. So I will answer this, no, if that is really true. Because I had an experience before, one of the owner of one brand of energy saver, they they would go to our office and they got my consultation services. So and we've got to Department of Energy and doing some testing there. So later I will tell you what happened to that testing in the Department of Energy. Okay, let's go first with the topic. Actually, this topic is a subtopic in our electrical engineering subject, the alternating current circuits. This is just a subtopic. I remember when we are a third year in electrical engineering, when I was studying in electrical engineering, this is the second to the last topic before we go to three-phase system. So, power factor correction. So, what is power factor? No? So, ano ba yung power factor? So, please bear with us to our, if there are some non-Filipino students, practitioners who are watching us, no? And who will be watching us in our YouTube channel. So from time to time, I'll be speaking a little of our language in Filipino or in Tagalog, no? So that it will have a more spice or more emphasis on the topic. But our base language is in English, and we'll try our best. No, even though you're let's say Malaysian, you're an Indian, you're an American, you're a European, no, as long as you are English, you can speak and understand the English language, and we can guarantee you that you can understand fully. No, as long as you are listening fully. Also, you have to focus your attention in listening. Okay, so power factor correction. What is PERC? Is the ratio between the kilowatt and the kVA drawn by any electrical load. Although previously, I've already shown some definition of power factor. As you watch my sample review lesson, that's what we call our mentoring program. No, so our student would send their question related to our discussion, and then I will answer that. No? That is actually part of our review program. We call this as mentoring program. So this is a Q&A portion. So these videos that you have watched. Okay. So, and also if you are already also our student, you can send in some questions, no? And then we will answer this, and we will send you the video. Okay. So, if we mean power factor, it is the ratio between the kilowatt and the kVA drawn. But first, what power are we getting? Are we getting from the utility? I have to convince you first, what power are we getting? So, let's say we have a pole, distribution pole, then we have a transformer. And the transformer, of course, would supply a certain customer. Let's say we have a large industrial or commercial customer. Let's say you have a three-phase, three transformer here, distribution transformer. So this supply, let's say, quite a big customer. This one. What power are we getting from the utility company? I have to convince you first, because my student said, "Sir, we get the kilowatt because the meter reads kilowatt hour, so we are getting only the kilowatt." No? As we take a look here in our triangle. Okay, again, although I already showed this to you before, no? If you are listening to our mentoring program before this video, the previous video. So this is what we call our apparent power. This is our reactive power, and this is our real power. See? That one. So this is apparent, reactive power, real power. Okay. So the power factor is cosine theta. Cosine theta. What is cosine? So katoa, this is the adjacent P over S. Okay. And then our P, basically, the unit, usually, commercially, let's say we have a kilowatt, this is the kVA, and this is the kbar. Do you know what we mean by kbar? This is kilovolt ampere reactive. That is the reactive component. So we have here our P. What is P? Basically, that is in kilowatts. And then our S is in kVA. That is why you will see here that the power factor, okay, is the ratio between the kilowatt and the kVA drawn. Okay? So we have the kilowatt divided by the kVA drawn. The kilowatt is the actual load power. That is the actual load power. Where the kVA is the apparent load power. What do we mean the apparent? The apparent actually is the totality of, it is actually the total power, I would say. Here. I have to convince you first, what power are we getting from the utility company? Here in our country, in Metro Manila, we have Meralco. Okay? So, the Manila Electric Company. So, what power are we getting? Because my student said, Sir, it's kilowatt. It's because what is being measured by the meter is the kilowatt hour. Okay? So, we are getting the kilowatt. No? But my question is, what about the rating of the transformer? What is the rating of the transformer? The transformer rating is expressed in kVA, right? That is expressed in kVA. If you have your commercial or industrial building, you have your generator, and your generator would also have a rating in kVA. How is that? They are saying that we are getting the P. No? I think that's wrong. And that is absolutely wrong. What we are getting is the S from the source. Let's say from the generation side, to transmission, to distribution side. No? The power flowing actually is the apparent power. If we are getting the apparent power, we are also getting the kilowatt and the kbar. Because if we are to total, if we are to sum up these two, this is what we call the vector sum. The vector sum. So if we are to get the vector sum, okay, so this is a 90 degrees. This is a right triangle. That is the vector sum. What do I mean vector sum? If we have this as our S, okay, so our formula, it will be, we'll be using the Pythagorean theorem. So that will be the square root of the P squared, then plus the Q squared. That is what we call the vector sum. The vector sum meaning you are considering its magnitude and its direction or its angle. It's fine. Okay. And then in rectangular form in electrical engineering, so we have this, P. Okay. So for this case, we have plus JQ. Okay. So that is the vector sum. That's the vector sum. Although there are really a lot of theoretical considerations. You have to consider a lot of principles here. This is a very broad topic. I remember I conducted this topic to engineers, to registered electrical engineer, and then I remember there are two professional electrical engineers attended my lecture in IIT. I conducted this lecture in IIT before, few years ago. That seminar, it has a CPD points. Before you renew your last license, you have to get some CPD points so that you can renew legally, I mean. So, I remember this topic. So, this is a 2 days topic, 8 hours, 8 hours. Day 1, day 2, okay? So, a total of 16 hours. No? Of course, it's impossible for me to discuss all the 16 hours with you guys. This is just a... Yun lang. Ano ba English ng patikit? What's the English of patikit? This is... No. This is just a bit of the taste. This is just a sample. This is just a portion. A portion. What I can give you today is just a bit of the taste. Baka konting tikim lang, di ba? So, of course, it's impossible for me because we have a special webinar. We call this a self-paced special webinar. Now, if you will avail this program, you can access our complete videos in power factor correction. You can access this for 1 month, and you can also access this for lifetime. No? If you are interested, no, we are selling our videos. No? Or you can access, you can access our videos. No? We have a lifetime access. We also have a 1 month access only. No? Later, we'll go to that when we go to our marketing presentation later. Okay, so this is actually an additional special webinar that we will give. We will conduct actually. This free webinar is just a bit of the taste. It's just a sample lecture. It's just what we call an introduction. Okay, so please bear with us. It's impossible for me to discuss this up to 5 p.m. The details, the everything, and then the calculations. No? So the purpose of the pre-webinar is to know the fundamental things, the basic things. But don't worry, no? A lot of people don't know the fundamentals and the basics. No? You are already 1 step ahead with them. Okay? Did you get that? Are you getting me, mga kawerpa? Nakakuha ba tayo ng mga kawerpa natin sa Pilipinas? Okay? Are you getting me? Okay? So, kumbaga, patikim lamang po ito, no? Patikim lang to. Okay. And we are hoping that we can also cater a lot of electrical engineering and technology and electrical practitioners, no? Around the globe, no? That's why we are trying our best to speak the English language, and we want to cater all electrical students and practitioners, not only in the Philippines, but around the globe. No? That's how ambitious we are. Okay, so if we are to consider the power taken by the customer, it is actually the KVA, not the P. If you are getting the KVA, you are getting the Q. Not only the P, but also you are getting the Q. But what is the function? Later, I will give you the discussion. What is the function of the P? What is the function of the Q? If you already know the function of P and Q of automatic, you will know the S, right? Because that is just a vector sum. Now, let's go to our PowerPoint. The kilowatt, no? Since power factor is the ratio of the kilowatt and the KVA. The kilowatt is the actual load power, and the KVA is the apparent load power. If we mean apparent, so that is the total. The total. We mean the apparent. So the actual load. So meaning this is the actual. The actual. Okay. It is a measure of how effectively the current is being converted into useful work. Okay, again, it says that, said here, it is the measure how effectively the current is being converted into useful work. So there is actually an apparent current other than the current being used for useful work. I'll show to you that later. We have a vector diagram here. No? And more particularly, okay, the power factor correction or power factor is a good indicator. Okay, the power factor correction is a good indicator of the effect of the load current on the efficiency of the system. Okay, I will send this to you. Okay, let's have a little shortcut here. If we increase the power factor, we are also increasing the efficiency. But if we lower the power factor, we are also lowering the efficiency. If we decrease the power factor, we decrease the efficiency. Of course, we would love to have an increase in efficiency. You want to have an efficient system. Okay? Basically, what is the measurement? What is one of the measurements of the efficiency of the system? One is that you have a quality voltage. You have a not that too high voltage, but not a low voltage. It's not a good indication if you have a low voltage. If you have a stabilized, that's the right word. No? If you have power factor correction, there is what we call the stabilized voltage. If you have a stabilized voltage, what do you mean by stabilized voltage? I remember, no, if capacitor is a voltage regulator. What do we mean a voltage regulator? If the system don't have a capacitor box, the fluctuation, you would see the fluctuation. I remember when I was working in one of the utility company, they would have they have what we call the recording voltmeter. We call that as RV. This is recording voltmeter. So there is a handle here, and then there is a paper here. That's like an ECG. You know, there is a tick tock. Okay, there is a you will hear a click here. It's one. Subscribe. Okay, so for every 2 seconds, it will record the value of the voltage. If you will see this fluctuation, but that's too high. There is a high voltage on this side, a low voltage on this side. Let's say this is the base is 230 volts. Let's say the system has no capacitor. But if you put capacitor on the system, that will become stabilized. Although there's still fluctuation, but so it will be more uniform, no? So here you will see a lot of spikes here, a lot of high voltage, low voltage system. It's not good. If you have a low voltage system, what is the effect of a low voltage system? So your fan will not give you the right speed, a lower speed of your fan. Let's say your electric fan. You have a low voltage system. Your aircon will not be that cool if you don't have a normal voltage being supplied to your air conditioning system. Take note, if the motor becomes low voltage, the current being drawn becomes larger. That is the behavior. Pag nag-low voltage yung motor mo, yung kuryente tumataas. If you supply a low voltage to your motor, the current becomes higher or larger. Let's say your motor is 230 volts. You supply that with 200 or less than 200 volts. What will happen is that will draw a larger amount of current. So, there will be a more uniform voltage compared to this indication. You will see this one here. That's why I've shown to you the recording voltmeter. It's like an ECG. Sino ba na ECG na sa inyo dito? Electrocardiogram, right? So, if you have a capacitor on the system, it regulates the voltage. If you have an inductor in the system, you regulate the current. But for this case, you are regulating the voltage. That's one of the advantages of power factor correction. Okay. The higher the power factor, the more effectively electrical power is being used. So if we increase the power factor, that's better. Our system performs well. But as we said earlier, that power factor ranges from 0 to 1 only. There's no power factor that is negative in value, no, none. There's no power factor that is greater than 1. I remember when I was teaching to my alma mater in University of the East Caloocan, we would have an experiment. We have an experiment that is we call this as air core reactor. It's just a simple representation of RL circuit. Okay, and then there is a switch here going to the capacitor banks. Okay, this is a representation of the capacitor bank. And remember, there are some toggle switch, toggle switch is like this one, that switch, that one. So it's toggle switch so that if you increase the capacitance or the microfarad of the capacitor, the power factor will also increase. So this is a basic circuit. Of course, we have here meters. There are meters here. So we have, let's say, I remember we have a power factor meter here. So we have an ammeter here. We have a voltmeter here. So there are 10 trials. I still remember that experiment because I've been doing that for 12 years in my alma mater. They're the laboratory subject. So as we increase the microfarad, this RL circuit is a representation of the customer. Remember, any type of building, residential, commercial, industrial, institutional building, high-rise building, any type of building, it's actually an inductive load. Take note of that. No? Inductive po yan by nature. No? Okay? So, trial 1, if there are no capacitor back, so what will be the current voltage and the power factor, then the trial 2, you make some adjustment. Okay, you will close the switch. You will notice that as we increase the microfarad of the capacitor, okay, what happened here is the current reduces as we increase the capacity. I will tell you what happened to that 0 to 10 trial, from 1 to 10 trial. As we increase the capacitance of the system, the ammeter reading or the current decreases. But the voltage increases, but not that too high, just enough to maintain. No? If we are loading, initially there is no capacitor back. Especially if you have more inductive load, you have a low voltage system that would tend to lower or decrease the voltage if you have so many inductive load. The tendency is to lower the voltage. But if you have a capacitor back, this will try to maintain. Capacitor will try to help out here so that it will not fall down. It will not decrease the voltage. Okay, so let's go here. What is power factor? Power factor is the measure of the degree. This one definition actually I've researched. Power factor is the measure of the degree to which a given load matches that of the pure resistance. So we have a basis here, a resistance. How this load is being matched with the pure resistance. I will tell you the more economical power factor based from experience. Power factor is you have 0.92 to 0.96 is already enough. That's a good indication that you have a very good power factor. If you have a power factor less than 85%, it's not a good indication. This is 92%, 96%. That's just in decimal form. If you have a lower than 85%, it's not a good indication. Actually, the utility company, there are utility companies. Also here in Metro Manila, they would charge a penalty of 0.6% for every percentage point lower than 85%. But if you increase the power factor, let's say from 85% to 92%, there is a discount. This is what we call a surcharge or penalty. Surcharge. or penalty. This is penalty. But when you increase the power factor, you will have a discount of 0.3% for every percentage point higher than 85%. That's the advantage. Sir, why is that? If there is penalty, meaning we will the electric bill would increase. Why is that? This is 0.6. But if it is a discount, why is this 0.3? If that would be a discount, why is that? Because that is a business. Right? Why is this not also 0.6%? If that will be to be deducted to your electric bill. If there is an additional charge, that is 0.6. Are you getting me? Nakuha nyo ba yun? Bakit daw, for Filipino audience, bakit daw pagka-discount 0.3? Pag madadagdagan yung bill mo, 0.6. Bakit gano'n? Eh, negosyo yan. That is a business. Okay? That is being implemented in Meralco, in our utility company in Metro Manila, in some franchise area of Meralco. I don't know with the other. I can speak with other utility companies. What I'm discussing here is just the basic principles. Okay. Power factor equal to 1 if load appears as the pure R. Power factor 0 if the load appears as pure L and pure C. The pure L meaning inductance and the pure capacitance. So there's no power factor here. 0. For RL, the power factor is between 0 to 1, lagging. Which is, this is the majority of the building. That is the power factor of the majority of the building. Or I would say all. Not unless it becomes overcompensation. The building is overcompensated. What do we mean by overcompensation? Overcompensated. What do we mean by that? You have a wrong adjustment on your capacitor bank, no? Then your building would, the power factor becomes leading. If the power factor of the building becomes leading, you would see that in the power factor meter, let's say on the switchboard or switch gear. Sure. So our power factor meter becomes leading. It's not a good indication. Pag nag-leading, hindi po maganda yun. If you have a leading power factor, what happened is your capacitor bank, usually the shape is in cylindrical. What happened is it's like a pregnant woman. Right? Nabubuntis siya. No? So, or let's say this is like a isang lasinggero. Ang lasinggero dyan sa kanto. No? So those people who always drunk every day. No? One. This is dangerous. This may explode. This capacitor. That is overcompensation. If the system is leading power factor, what happened to your building or to your system? This is what will happen. Okay. This is the source voltage. I will make this as BS, the source voltage. And I will make this as BL, the load voltage. Of course, there are, let's say on the distribution or transmission line, and even in the building. So, especially if you have a longer conductor here, there is an inductance. Resistance and inductance, the parameter of the line. Only the transmission line, they have what we call the capacitance of the line. I will not be talking about that. That is for the case of the transmission line. But for the case of a building, let's say. So, if this is your load, considering it's your load, let's say we have a per phase analysis here. per phase analysis. This one. If this is our source voltage, Vs, this one, source voltage. It's like a short transmission line, no? This one. If the power factor, you see this one, this is an inductive load. This load is an inductive load. That is inductive load. So, naturally, the voltage of the load is lower than the source voltage. Why? Because there is a voltage drop here. The voltage drop here. No? There's a voltage drop. What is a voltage drop? What is a voltage drop? Okay. Okay, son, please give this to your little brother. I have 100 pesos. You give this to your little brother. Yes, Papa. But he only receives 70 pesos. From 100 pesos, he receives only 70 pesos. But where is the 30 pesos? Voltage drop. You see? Saan napunta yung 30? Voltage drop po yun. No? If we have a source voltage here, let's say in the building, let's say you have your 240 volts or 250 volts near the transformer. Then go into your panel board, go into your load, 240 volts, then you have around 230 volts here. Where is the 10 volts? Here. The 10 volts goes to, that is the voltage, no? Drop to your either line, to your line or to your conductor. So that is the voltage drop. There is a voltage drop here. Let's say you have a voltmeter to measure the voltage drop. So that is our V sub P. That's one. See? That is our V sub P. So that we would have an equation of V sub S. V sub S is equal to the V sub L, the load voltage plus K. Let us consider there is a current flowing here. The current I here. That is the current I. So that will be IR. The R, let's say here. Although there is an inductor here, no? So we can have this as Z. But for the meantime, let us disregard. Let us ignore first our X sub L here. Take a look. This is a basic equation. Take a look here. If we are, this is the source voltage, the load voltage, this is the voltage drop. As we multiply this, no? So I multiply natin. If we multiply this by I, what will happen to our equation? That will become Vs I, okay? That is equal to VL I, and then plus I squared R, okay? I squared R. Now, what is this equation? Basically, the VSI that is on the source side or on the line side, that is actually our power input. Power input. And that will be equal to, what is this VL multiplied by I? That is the power consumed by the load itself. So it is the power output. Please take note. If we mean the power output, that is the power consumed by the load. Absolutely. That is minus the power on the lines, no? The power dissipation on the conductors. Okay. Because this is the power dissipation or the power loss, what we call the power loss or power losses. This one. Again, the power input is Vs multiplied by I. The power output is VL multiplied by I. The power loss is I squared R. That one. And we can have an efficiency. The equation for the efficiency, that is the basic equation. the power output over the power input times 100%. Okay, so if we having the power output here over, what is the power input? That is the power output plus power losses, or power loss, multiplied by 100%. Okay? We have said before that if we increase the power factor, if we increase, let's say from 70% to 92%, if we increase the power factor, the efficiency would increase. Why is this? Why? What happened? Now, what happened? If we increase the power factor, we increase the efficiency. Although we have said that if we increase the capacitance, we are increasing also the power factor. But the current decreases. You see, I've said this before, the current decreases as we increase the power factor. Basically, that's the reason. But how is this? What's the basis? What's the basis? Okay? We'll go that later. I will show to you the current triangle. I'll show that to you. Sige, ngayon na. Ngayon na. What is the current triangle? The current triangle is this one. Although I have also this in my PowerPoint presentation. Unahan na natin siya. Okay. So, take a look here. There is current flowing here. Let's say this is the IL, the load current, IL. Take a look here. The current flowing here, that color blue, is the load current, IL. That is our IL. The IL is this one. This is our IL. Let's say a lagging power factor. This is the load current, IL. Okay? That is our IL. That is actually the vector sum of our two currents. One. Let us call this as ILX. And there is an imaginary component. If I mean imaginary component, that is being reflected on the y-axis. This one. Let's call this as ILY. Okay. So, IL is the vector sum of ILX and ILY. No? So, by Pythagorean theorem, you come up with this equation also. Just replace this by ILX and this is ILY. This is our IL. Okay? So, if we put capacitor on the system, what happens? If we put capacitor on the system, there you are. It's like this one. If we switch on this capacitor, what happened is there will be a leading current. If that leading current is this current, if the current is downward, that is lagging. If the current is upward, that is leading. Okay? I have to apologize to non-engineering courses. If you're not an engineering student or graduates, I have to apologize. It's really it's an engineering subject actually. This topic, but we'll try our best so that even just a little knowledge you will get today, in your pocket. Okay, so para hindi naman masayang yung araw nyo. So it will not be put into waste. So we'll give you a basic knowledge and understanding. So I know, I presume, if you are an engineering student or graduates, you can easily understand this discussion because we've gone through this before when you were in college, right? It's just a review. So, the capacitor, let's say that there is a current flowing in the capacitor here. That is what we call an IC. IC. Okay? What is the IC? International, huwag na lang. Sorry. So, yun kasi dito sa may atin, sa may Second Avenue nun, partner, di ba? IC tawag nila dito. Kuli-kuli. Okay, so, the capacitor current is a leading current. That is a 90-degree current. 90-degree current, that capacitor. Now, we will reflect this current here. Let's say this is 2 inches. I will reflect this 2 inches here. That one. Actually, there is a projection here, no? Just like matrix projection of Scheider. You know Scheider? Matrix projection. There is a projection here. Now, if this is our IC, the new current, I will call this as the total current. Because the total current, can we see the current? Yes. The total current, that will be your load current plus your capacitor current. You see here? Now, the vector sum of the load current and the capacitor current is this. Take a look here. I'll show this to you, the red one. This will now be our total current. You see, what happened to the current? Decreases or increases? Before, if we don't have a capacitor, the current is IL. Okay. The source will deliver IL here. Okay, this is our IL. But when you connect capacitor here, that grows a leading current, not a lagging current. Always remember that inductance and capacitance, they are always opposite to each other. They are always opposite. Kontrapelo yan, kontrabida yan. Parang Ginebra at Alaska yan. No? Nakasampung straight na panalo Ginebra. Pagdating sa Alaska, talo nung araw. Noong 90s yun. Also, what happened is the current decreases. This is now the new current. You will see that this is larger than this. Mas malaki ito kaysa dito. Lumilit yung kuryente. The current decreases. You will see here. Okay? That's the beauty of power factor correction. The current decreases. Take a look here. From the equation, if the current decreases, what happened? What happened if the current decreases? Of course, the power input will decrease. The output will decrease. The power loss also decreases. Right? For any value, when you decrease the value of I, of course, that will also decrease. Siyempre, pag pinababa mo yung kuryente, bababa din yung power loss, bababa din yung power output, yung power input, bababa din. Natural. No? Bababa yun. Okay? When you decrease the current, the power input, output, the power loss decreases. Basically, the power loss decreases. The power loss decreases. When you decrease the current, the power loss decreases. Of course, when you decrease the power loss, what happens? This power input will decrease. Once you decrease the power input, of course, the efficiency gets higher. Because this is inversely proportional, right? Inversely proportional. By the way, this current for PL is IL. For input, that is our IT. Okay? If you already have your capacitor, this is your IT. The power output is the power consumed by the load itself. Minus the line, the feeder lines. No? Minus those lines. The feeder, the sub-feeder line. Theoretically, the power output is constant. It doesn't change. by the way. Because this power output, remember the power output is also our PL. It doesn't change. Meaning, what is the power output? The power at the load here. Okay? That is the power output. If you have a watt meter, whether there is a capacitor or no capacitor, the power here is constant. What is being done by the capacitor is it reduces the power loss. Pinapababa niya yung power loss. Ganun ang ginagawa ng capacitor. We'll go through that later. We'll go back to this principle. I think I'm parang bumibilis ako sa discussion dyan. Dito muna tayo. Okay? Hinay-hinay lang. Okay. So, let's go here. RC, the power factor is leading. If we have capacitor on the system, there's a tendency that the load becomes leading power factor. Take a look here. Most loads on the electrical distribution system can be categorized into three parts. We have resistive, inductive, capacitive. Of course, we mean resistive, there's a presence of a pure R. What are the samples of these loads? What are the sample of these loads? Okay, sound check. Do you hear me? Okay. Rinig po ba mga kawerpa? Gets ba? Thumbs up na kung rinig tayo. May yata kayo eh. Okay. So, most of the loads has a lagging power factor. Lagging power factor. If that is lagging power factor, that is inductive by nature. If that is leading power factor, that is capacitive by nature. I'm sorry, this topic concerns with a lot of electrical principles. No? Just in case you are interested to avail our special webinar, so that that is a more profound discussion. That is a more deeper discussion. Okay. So most of the loads are inductive. It becomes capacitive when the capacitor becomes overcompensated, overcompensation. As I've said, no? Overcompensation, that tendency, remember this, if we mean overcompensation, the tendency for the load voltage is it becomes higher than the source voltage. What about that? Higher than the source voltage. The load voltage becomes higher than the source voltage. So mas malaki yung load voltage kasi ang the natural is Vs is greater than V sub C. The Vs is greater than VL naturally because of the voltage law, right? But if your load is lagging power factor and also unity power factor, the Vs, the source voltage is greater than the load voltage. But if your Vs is less than the load voltage, or the VL is greater than the source voltage, what happens? The system becomes leading. Again, that is overcompensation. The load voltage becomes greater than the source voltage. Take a look here again. If we have a resistance R, let us disregard first the inductance. One. We have the load here. So this is our source voltage. is our load voltage. This is our R, and this is our I. When the load voltage becomes greater than the source voltage, it becomes a leading power factor. That is what we call, there is an effect. What is that effect? That is what we call the Ferranti effect. Ferranti effect. See? Ferranti effect. It's not natural, actually. No? The load voltage is greater than the source voltage. Okay, let's go here. On modern system, the most common is the inductive load. A typical example includes transformers, fluorescent lighting, induction motors. Inductive load meaning there is a presence of coil. Okay. Again, for the resistive load, pure R or resistive load like your flat iron, the incandescent bulb, the posters, heaters, those are resistive by nature. Inductive load examples are those loads that has a coil. Okay? Like our lighting system, our fluorescent lighting, motors, induction motors, transformers. Those are has coil in it. A common characteristics of these loads is that they utilize the winding in order to operate. Okay? So that is the characteristic of the inductive load. They utilize the winding in order to operate. This winding produces an electromagnetic field. See? This winding or coil, this coil produces electromagnetic field which allows the motor or transformer to function and requires a certain amount of electrical power to maintain this electric field. Meron palang kailangan na power para ma-maintain ito. Ano yun? Anong power yun? No? Again, ulitin natin ang basa. Basa. This winding, the winding or the coil produces an electromagnetic field. So, for the case of the motors, it's very important to have an electromagnetic field. Without electromagnetic field, your motor will not rotate. That is why in the motor, we have what we call the revolving magnetic field. Take a look here. This winding produces an electromagnetic field. No? Our motors, transformers, even our relay has an electromagnetic field. This winding produces an electromagnetic field which allows the motor and transformer to function and requires a certain amount of power. See? Produces electromagnetic field. And this electromagnetic field requires a certain amount of electrical power to maintain this electric field. You see? What is that power? Is that S? Is that P? Is that Q? Let's see. What is that power? Okay, we'll go back here. Take a look here first. This is a motor, a representation of any type of or all type of building. We have said that all types of building, it has inductive load, especially industrial plant who has so many transformers, so many motors. Active power, another term, no, for true power, real power, another term is active power. That's the kilowatt. It actually performs the work. What do we mean performs the work? For the case of the motor, so that it will rotate properly, we need the P. We need the P to function properly. And that is the work. Okay? The work is the product of force and the distance. There is a force here. For the case of the motor, there is a rotational force. For us to have for the motor, not us, the motor, okay? The motor would require active power so that it will rotate. But we need, for the rotation of the motor, we need to maintain this electromagnetic field so that you will have a continuous magnetic field and the motor will rotate continuously. We need a reactive power K-bar. You see? It's quite sad for me. I've read some book, this one book. Another term for active power is the useful power. Okay, I agree. Then he termed the reactive power as useless power. I disagree. Sir, marunong pa ba kayo sa auto? Are you better than the auto? Of course not. But for me, I disagree with that book. That one particular book I've read. I will not tell you who is the author of that book. He said that reactive power is useless power. I disagree. Why? Because reactive power, many books would say that reactive power maintains the electromagnetic field. You see? Kaya nga umiikot yung motor dahil may electromagnetic field. The motor rotates because there is a magnetic field. The generator produces voltage or generates voltage because of the magnetic field. There is a certain power that needed to maintain this magnetic field. And that is what we call the reactive power. Kasi kailangan mo na reactive power. Paano mo sasabihin useless yan? Oh, useless yan. Useless power. Reactive power is useless power. I disagree. It's not a good book. Okay, so it's not a useless power. But what I can say is reactive power is like a sugar. You know sugar? Do not eat a lot of sugar. That will cause you diabetes, right? Do not eat a lot of sugar. We just need a little sugar, a little amount of, or enough amount of sugar. Not too low, not too high. So, sakto lang, ika nga, no? Just a right amount of sugar we need. What happened to your child? No? Nangingisay, no? Nangingisay yung bata. What happened to your child? Oh, he has a low sugar. So, sinaksakan ng lollipop ba naman? Pero mo, sinaksakan ng lollipop yung anak niya. Yung pala yun. No? Meron palang tao, there are people who has low sugar. What is the parallelism of this? We need Q. This is the K bar, reactive power. That is the Q. This is the P, this is the Q. We need a little K bar. But we don't need a large K bar. It's not nice to have a large K bar. It's not nice. I don't know if I can finish this topic today. Maybe we would have a part 2 next week. I think wala pa ako. I did not, so far, I think I just gave you 20%. Let's see. I can shortcut this. So, if not, we'll have a part 2 next week. So, active power. Active power performs the work. Reactive power maintains the electromagnetic field. We need the electromagnetic field. Without the electromagnetic field, the motor will not rotate. The relay will not function properly. Even the circuit breaker, there is a magnetic operation, electromagnetic operation of the circuit breaker. So there is a certain power required so that magnetic field must be maintained. What is this magnetic field? Kuya Reg, ano ba yung magnetic field na sinasabi mo na yan? Okay. Let's say this is a conductor. If we inject a current here, this is a current flowing. This is the current I. That generates a magnetic field. That generates a magnetic field. You see? That is governed by the Ampere's right-hand rule. What happened here is like this one. See? It moves on the clockwise direction. If the current flowing is going to, well, you're facing, that's going to the, di ba, kanan? Kanan, right. Let's say the direction of this current is going to the right, and then you will have the magnetic field on a clockwise direction. Clockwise direction. This one. Sinasabi ni Ampere's right-hand rule. From the Ampere's right-hand rule. This magnetic field is any conductor. Any conductor. You see, if there is a distribution pole here, and you would see the conductor here. Okay, this is your transformer. There is a current flowing to your primary distribution line. There is a certain magnetic field here. Don't you know that? There is a magnetic field encircling to this conductor. That is the reason why the distribution line must have a certain distance. This is being designed by the engineers, distribution engineers. No? So you have to consider the distance of this. Let's say this is a three-phase. There is a magnetic effect here. Okay? So magnetic field is very important. The rotating magnetic field of the motor, let's say you have a motor here, even generators. So there is a magnetic, revolving magnetic field, I should say. There is a revolving magnetic field. Basically, the magnetic field would flow from North Pole going to South Pole. There is a resultant magnetic field revolving in the motor. Okay, that's why the motor rotates. Well, we'll have a separate topic for that. Actually, you can also watch my YouTube channel related to a motor operation and principles. So we already uploaded that video. Okay, so we have learned here that the power being taken by the load is R, not is, R, the kilowatt and the kbar. We need real power or active power. It performs the work itself. You need the force. Yeah, you need the distance. For the motor, you have to rotate that. There's a certain force. Actually, that's what we call the torque, right? The rotational force of the motor. The torque. In engineering mechanics, I remember, it's the moment. Right? The force times the distance. Reactive power kbar sustains the electromagnetic, sustains or it maintains. Without the Q, there will be no electromagnetic field. There will be no electromagnetic field. So it's very important. So it's not useless. Sorry to that book, to the author of that book. That's how I studied. Even when I was in college, in electrical engineering. Kagad ako naniniwala doon sa libro. No? May ganun akong attitude. Hindi ako kagad naniniwala. Ang gagawin ko, pupunta ako sa ibang libro. No? Punta ako sa library, mo na ibang author naman. Magre-research ka. Dapat ganun kayong klaseng estudyante. No, huwag ka kagad maniwala sa isang libro, titingin ka doon sa iba. Dahil hindi na tayo nakikindihan ng mga foreigner. So, okay. So, you should have always a basis. No? What I'm trying to say is reactive power is not a useless power. That is also useful. Okay, once we get the real power and the active power, of course, we are getting the swan. Take a look here. This is the building. We are getting the active power, the P, the active power, the Q. Of course, automatically you get the apparent power. Will you thumbs up those people in the Zoom class? Kung naiintindihan ba ako? Hindi ata ako naiintindihan. Tingnan natin kung naiintindihan ako dyan. Ma-aware pa natin. Okay? I think, partner, di ko matatapos ito. Mention na kayo, first time lang namin tinuro ito ng mas maraming English. Okay. So, one common example of reactive power can be seen in an unloaded AC motors. So unloaded, meaning there's no load, no? Take a look here. When all loads are removed, okay, you remove all the mechanical load of this motor, no? One might expect the no load current will generally show a value between 24 to 30%. Well, it's true. If your motor has no load, it will draw a smaller amount of current, no? Compared to its full load current. What do you mean by full load current? Basically, the full load current is the nameplate current. Once you see, actually, I have that discussion before. No? Alam, nakatablish. No? We try our best to make it a more English discussion. So, about motors. So, the no load current would show 24 to 30% of the full load current. For example, you have a 100 amperes motor. 100 amperes. It will draw around 24 to 30 ampere at no load. Once you put a load, okay, going to the, let's say 50%, 70, 80% loading, 100% loading is already what we call the full load. And remember, we conducted that experiment in the university. We load the motor. Once we increase the load, okay, the current being drawn by the motor also increases. But when you overload the motor, it's more than 100% loading, what happened to the current being taken by the motor? It also increases. And that is what we call the overload current. Pag sumobra na, mas malaki na doon. Makikita mo naman sa clamp ammeter mo eh. You can see that in your clamp ammeter. In the nameplate, it's only 100 ampere. In the clamp ammeter, the actual current here is already 110 amperes. So yeah, that is already overload current. Okay? This is because the continuous demand for magnetizing current by any inductive load. Active power or real power is the total power indicated in the wattmeter. Yung sa wattmeter, yun. Kasi nga, sinukat nga niya yung active power na, kaya nga wattmeter. Don't you know that is a bar meter? There is a BA meter. Apparent power is the combination of reactive and active power. I hope I already convinced you that the power we are getting from the utility company is not the P only. It is the S. It is because we need the Q. Again, to maintain the electromagnetic field. Did you get that? Raise your hand or thumbs up. Para man lang merong konting tawag doon. Interaction man lang. Ayan, okay. So sana na-convince ko na kayo doon, makaka-aware pa, no? Na ang kinukuha talaga na, kasi yung iba talagang makukulit, nakikipag-debate pa sa akin, they even have a debate with me, even though they are just a student. No sir, what we are getting is the P. Because of the kilowatt hour. Eh siyempre, nakatingin ka sa kilowatt hour meter eh. Eh sinusukat nun talaga, P lang eh. No? What is being measured in the kilowatt hour is just the P itself. Absolutely P only. But there is a BA meter. There is a K-bar meter. There is a KVA meter. If you go to a large scale, to a large industrial customer, they would have a lot of meters in their switchboard, switchgear. Okay? I hope I already convinced you. No? Okay, let's have an ideal comparison of the effect of power factor on the system. Okay, so without capacitor, this is without capacitor. This is with capacitor. Let's go first to without capacitor. I would say this is ideal. Ideal. Take a look here. Without capacitor, no, kung wala tayong capacitor, this is the utility company. What we are getting in the utility company is the red one. What is the red? The active power, meaning that is the kilowatt. The blue one is the reactive power. We are getting both of this power in the utility company, wherein if your building has a capacitor, take a look here. You are only getting the red one. This is the kilowatt, the P, from the utility company. But your load needs the reactive power. We said that before. That will be the function or use of the capacitor. Your capacitor is what we call the reactive power generator. Your capacitor will give you the necessary Q so that your motor or your building will function properly. I hope you get that point. I should say this is ideal. Ideal. Why is it ideal? Actually, the utility company would still give you the reactive power, but it decreases. How is that? Take a look here. I'll explain this one. I discussed to you the current triangle. Now I will discuss to you the power triangle. Okay. I will discuss to you the power triangle. I think this will be the last portion of our webinar. We will continue this, partner, next week. So, let us take a look here. We have a simple circuit. And that it is a single phase or three phase in principle. Again, this will draw IN. Okay. This is the source. I already showed to you the current, the effect of current. Let's go now to the power. To the power. Let's say this will supply your S. That will draw the S of the load. So let's say this is our S. S is the KVA. The S of the load. One, the S of the load. That can be break down into two components. What are these two components? The two components are PL, and then this is our EL, and this is our QL. One. Okay, this is our angle, the theta or the angle of the load. That's why if you have a certain power factor, let's say theta L, let's say you have your load is power factor initially, let's say you have your 0.8. I will calculate. Okay, so that is 36.87 degrees. Okay, so I memorized this already because this is the most popular power factor in the board examination. Okay? So, 36.87 degrees, that is the angle here. Remember that SL is the power consumed by the load. Apparent power, apparent power consumed by the load. Now, if we put a capacitor on the system, what happens? We put a capacitor on the system. I put here, what will happen? Whether it is single phase or three phase, just the same principle. What will happen? The capacitor will draw a reactive power. Remember, this load is an inductive load. The QL is on the downward direction. And then this will draw QC. The QC is Quezon City? No, it's not Quezon City. It is, ano yan? Ano yung QC natin? What is this QC? That is against the QL. I've said before that they are actually opponents, the inductance and capacitance. They oppose each other. No? They oppose each other. So let's say this is QC, this one, QC, QC. I will project this size. Let's say this is 3 inches. I will project this size here, just like what I've done before for the current. If that is QC, this is also QC. One. And then we'll come up with the S total. What is S total here? From the origin going here, that is our S total. What is our S total? It is simply the vector sum of the SL and SQC. That is the S total. Okay, by Kirchhoff's current law here, the current entering is equal to the current leaving, right? But vectorially, this is ST is equal to SL, okay, plus QC. Or you can put here for the complex number, okay. I'm sorry, this would be very hard for the part of the electricians or non-engineering courses. So this is a complex number. Or it's just simply, let's say, for the purpose of discussion, you just have, that is the sum of SL and QC. But it is the vector sum. Because QC is 90 degrees. 90 degrees. Anyway, if you want to understand this J, I had my in my YouTube channel about the complex number. You can download that. No? Just type Reggie Marina and then complex number. I have a discussion regarding complex number so that you'll have an idea. Okay, so you will see here that ST is lower than SL. That is shorter, right? That is shorter than SL. You would see. No? Kumbaga, makikita mo, lumiit yung no? Lumiit yung ST natin, di ba? Lumiit yung ST natin. Okay? Because there is an opposing effect between these two. The QL is always downward, the QC is always upward. So you would see here, to get the vector sum of, to come up with ST, that is the SL plus QC. So you will have this value. You have that value. I'm only discussing the principle. I have a lot of example in my special webinar. No? If you want to avail, no, you may avail. No? If not, it's okay. At least you have a basic knowledge. Okay, so let us go here. Okay, I will explore more this vector diagram. So this is our QC. Okay. Take a look here. I will derive an equation to get the size, the Q of the capacitor. It's very important. Let's say we want to design how many K-bar are we going to use. How can we compute for the K-bar? Okay, I will derive this equation. Take a look here. So let's say this is our QC. This is our QC. Okay. Originally, this is our QL, right? That is our QL. So let us put here QL. QL. See? That is QL. So what is this one? Take a look. We have here our ST. That can be breakdown into two components. The ST, that will have a PT, which is equivalent to our PM. Huh? Our PT is equal to PM. But what will be this portion? That is our QT. Yeah. No? So this is our QT. Okay. Geometrically, our QL, okay, so dito ko na lang lalagay. I just put here. Our QL is equal to QC plus QT. Plus QT. Okay? Now, what I need to get is the QC, the K-bar of the capacitor. The QC is equal to QL minus QT. See? Now, let us go back with the basic power triangle. This is the power triangle. This is S, this is the theta, the P, and the Q. Okay. I will get tangent theta. I will get tangent theta. What is tangent theta? SOHCAHTOA. That is the opposite over the adjacent. The opposite is Q. The opposite is Q over P. Q over P. So our Q is equal to P tangent theta. Our Q is equal to P tangent theta. Okay? So, naalala ko nung maliit ako ang bata. Kasalanan ako sa father ko. Tanungin nyo, ano yun, sir? Kasalanan ko nung maliit akong bata para makabili ako ng candy. Kinukupitan ko siya. Kupitan. You see? Kupitan. What did he say? American student would say, Indian, forget it. That is for Filipino student only. So it's very hard for me to convert that in Tagalog. Okay, so I've said before that from time to time I'll be speaking a little Tagalog. But if you will absorb all my English statements, that is already enough for you to understand the lesson. So later I will study how to make some English jokes. Okay, it's very hard. So we have this Q that is equal to P tangent theta. Kupitan. Ano ba English ng kupitan? Oh, mahirap, di ba? Mahirap. Okay. Sige. Q is equal to P tangent theta. Let's go back to this equation. QL, QT. Okay? So, I will rewrite here. The QC is equal to QL minus QT. Now, we have said that Q is P tangent theta. I will put here P tangent theta. But, this is PL This is tangent theta L minus, okay, the Q here is P tangent theta also. But if there is a P here, there is also a P and T here. This is the QC. Take a look here, guys. Take a look. The QC, okay, by the way, where is our theta T? The theta T is the smaller angle here. That is the smaller angle. The theta L is the original larger angle. The theta T is the smaller angle, the new angle. In some other books, they call the theta L as the old, theta old. And the theta T is the theta new. No, I've seen a book like that. This is theta old, this is theta new. But for me, I just designate it as theta L and theta T. If I mean T, that is the total. T is total, meaning it already has a capacitor, meaning the load plus capacitor. That is why it is total. There is a load plus the capacitor. Now, the QC, since PL is equal to PT here, we can factor out. I can put here on the PL because the PT here is equal to PL. Now, we can factor out PL algebraically. So we will come up with this equation, tangent theta L minus tangent theta T. So that will be our formula in getting the K bar of the capacitor. If we have, let's say, 36 degrees here, put 36. If we have, let's say, 25 degrees here, let's say R cosine of 0.9, how much is that? Around 25 degrees. Can calculate, put here, and then let's say you have 100 kilowatt for your load, and then you cannot calculate for the Q of the capacitor. I'm sorry, I don't have the luxury of time. No, we have to discuss something here for the next portion. So, well, we may call this as just a part 1. No, so we will have our discussion, the part 2, the more detailed discussion next week. No. We'll discuss also how power factor correction is being implemented by the utility company. No, it's a very practical discussion. It's not being discussed in the university. No, we will have a more detailed discussion next week, next Sunday. I hope we can see you again. No, but this is just an introduction. Okay, I've said this is just a bit of the taste. Okay. Tama ba yung aking ano? So, okay, so that's it for this topic. We'll go to our marketing presentation, and we will continue the discussion of this next week. Thank you, and we'll see you next week. Okay, but by the way, we are not yet finished. Salamat po. Okay, mga kawerpa, so this is our review center. Okay, here's the name of our review and training center. MPHT stands for Marinized Powerhouse Team Review and Training Center. So Marinized stands for my surname, actually. So because the power is in the house. Okay, we are offering free webinar. This is every Sunday, 1:30 p.m. to 5 p.m. Philippine time. I don't know what is the time in your country, no? Because we have the different time zones. So this is brought to us by UN Television, your public service channel, and the IIEE. No? That's why we are giving this for free, no? Free of charge. No? So wala kayong gagastusin dito, no? Free of charge. Kasi meron na po tayong sponsor. No? Magandang loob po sa atin ang UNTV at ang IIEE. No? Palakpakan naman natin ang UNTV at IIEE. Okay. Palakpakan naman natin sila, no? Kahit pa paano'y nakapagdagdag ng kaalaman, no? Nakatulong po ng kaunti, no? So, hindi man namin masabing malaki ang naitulong namin sa inyo. Maliit lang yan, no? Para sa amin. At kaya inihikayat namin kayo na every Sunday, no? Para lumaki naman, no? Ang aming maitulong sa inyo, sana every Sunday, connect po tayo. So, we want to help everybody. So, everybody is welcome to our free webinar. Okay. Later, do not leave. No? We will send to you the link for our free e-certificate. Okay, this is the name of my YouTube channel, our YouTube channel, the Reggie Marina YouTube channel. Here's my nickname and my surname. So please do subscribe, like, and share. Okay, let us have an update. No? I-update namin kayo as of October 23, kaninang umaga lang to. No? 11 a.m. Your subscriber, no? Sabi ng YouTube, your subscriber has 13,100 subscribers. Now, if you are not yet a subscriber, so please do subscribe, like, and share. And put a comment. No? Put a comment. No, we may not be a perfect teachers, but we try our best, no, for you to understand the lesson. Number one is we want to help everybody. Our channel has gotten 530,298 views so far. So, lahating million na po tayo, mga kawerpa. Salamat po sa mga nanood ng mga videos natin at kung po pwede, mag-request po sana kami sa inyo. Kung po pwede, pati yung commercial, segundo lang naman yan. No? Pakipanood po natin. No? We want everybody. No? So please, no? Just a little of your time. Please also watch the commercial in the video. Okay? Once you subscribe. And we also have our private group, the MPHT Review Center private group. So far, we already have 3,600 members. Okay, so we are inviting everyone, no, to be the member so that you have a first-hand information. Okay, for our activities, no, will be updated. Okay. So we have an extension to our early bird promo, our online review course via Zoom for April 2023 RE R&D board exam and February 2023 Master Plumber board examination. There are some students asking me, sir, can I also avail your review program even though I'm just a student? No problem. No, even sir, I'm not a Filipino. Ganun ba? No problem. No, if you want to learn something, no, maubliga tayo mo English sa review nito. So everybody is welcome. No? So if you want to avail to our review program, no, because this is designed for the licensure exam here in the Philippines. So the registered electrical engineer, registered master electrician, and registered master plumber online. This is online review via Zoom, no? As low as 6,000 for REE, 4,000 pesos only for RME, and 5,000 pesos only for RNE. Okay, so we extend the promo up to October, next Friday. What's that? October 28. No? October 28. Yan na po ang last day ng ating promo. No? Especially, no, maraming nag-enroll din sa atin, especially to those who are interested in registered master electrician. As low as 4,000 pesos only. No? So, that is complete subject. No? For REE, that's complete subject. No? Math S as E. For RME, technical subject, and PEC will be discussed. No? And also for Master Plumber, as low as 6,000, 4,000, and 5,000 pesos only. We also have what we call the self-paced review program. No? The difference is you can review anytime you want, anywhere, no, as long as you have internet connection, and any number of times you can view, you can watch our videos over and over again. No? If you want to watch our video 2 times, 3 times, no problem, no problem. So you will have an access, at least a 5 months access to our original review videos. Okay, we have available for RE, RME, and also for Master Plumber. We also have that. No? So you may correct this to April 2023. No? So applicable to April 2023 also. And then we have a webinar series with e-certificate and 3 original videos for only 249 pesos per topic. So there are 30 topics to choose from. Okay. So you may avail, no? Baka hindi niyo pa na-attendan before yan. So you can have your own e-certificate. And we have, this is our self-paced special webinar. We have the building wiring installation. So you can access our video, no, from 1 month, no, 1 month access per topic. Okay, so just give us a message on a Marinais Powerhouse Messenger account. So this is our next topic, the industrial motor control. Those are the topics to be discussed. The practical electrical design course. The module 1 is residential. The module 2 is commercial industrial, and module 3 is the high-rise building electrical design. No? Just in case you are interested, just send us a private message at Marinais Powerhouse. We also have practical electrical estimation course. Okay, we also have a self-paced special webinar on engineering math with calculator techniques. This is for engineering students, reviewees, and those who would like to study ETIAP. Let's say these electricians or technicians want to pursue a course in engineering for 1 year only. Okay, so we have a mathematics discussion for only 5,990 for 2 months. This is a 2 months access. So if you're interested, just send us a message at Marinais Powerhouse, no? Our messenger account. So special webinar, how does an electrician become an electrical engineer in just 1 year? This is through CHED ETIAP program. Then we're inviting you to be a member of the ETIAP BSE mentoring, no? Those electricians or technicians who wish to become an electrical engineer, no? So Engineer Joel Elige will help you out, no? He was our former student, Engineer Elige. And here's the school that offers a 1-year college diploma, college degree in engineering. So one of that is electrical engineering. This is what we call in our country, what we call the expanded tertiary education equivalency and accreditation program. So you may go to this school or to their website or to their FB page. So just type Manuel S. Enverga University Foundation. Actually, the school is in Lucena City, no? In Quezon Province. But they have online classes. No? You may inquire to them. Okay. So we also have special webinar, how to become a certified chief electrician and an electrotechnical officer. So yung mga nagbabalak dyan magbarko, no, to work in the ship or in the watercraft, no, so this is a helpful topic for you. Okay, our speaker for this topic is ETO Virgilio Daniel Jr. He's a registered master electrician. He's an electrotechnical officer. Siya po yung in-interview po natin, yung napanood niyo po, na napakita naman, ano? So, siya po yun, mga kawerta. Okay, so this is our original REE books, just in case you are interested. Okay. These are some of our customers who avail our books. These are REE books. And we also have our RME books. Are some of our good customers. They sent us a message if you want to order our books and Master Plumber books, review books. Now, these are review books, no? Useful in the licensure examination. This is the contract signing between our national organization and the NPHT Review Center. Well, IIE is a multi-awarded organization in our country. So they consider our center, no? To be one of their partner with the help of Engineer Alan Alvarez. He is the 2021 National President because we signed this last November 4, 2021. Here is Engineer Alvarez and this is me. Okay? Ito po ang inyong lingkod, ano? So kami po yung nagkaroon ng contract signing before. That contract signing was conducted at Cubao in Quezon City. There you are. And the 2022 president, by the way, is Engineer Feliciano Padua III. That one. He is Sir Jojo Sir Feliciano. No? Last November 4 last year, no, he posted this to his Facebook account. No? Train CPD, Marinex Powerhouse Team, RE review materials for IIT Team Library. You see? So they have our book. No? This is what we call the IIE UID partner. So if you have this ID, no, so it's only 200 pesos, you will have additional discount to our review program, to our special webinar, 10% discount. And this is just 200 pesos. No? You may avail this, no, with them. So you may go to their office or you may call to their numbers. No? You can see that in their FB page, in their website. Okay. Okay, there is Jojo, our president, present president, Engineer Padua III, and Engineer Alvarez was last year president. Okay. Ayan po, kaming tatlo, mga kawerpa. There you are. Okay. This is contract signing, no? And it's really a great honor to meet our national president. They are professional electrical engineers. No? They trusted our center, so we want to thank them, no, for giving their trust to our center. Salamat po. Okay, so we have what we call Promote Ko Electrical Products Mo. So let us update our practitioners and students in the latest trend of electrical technology. So we will bridge the gap. There is a big gap between the academe and industry. This is the academe, this is the industry. So there is a far distance. No? So kaya yung estudyante, pagpunta niya sa field, nagugulat siya sa lawak ng technology. No? Dito pa lang at least, dito pa lang sa ating center, maituro na po natin, ma-upgrade natin sila kung ano nangyayari sa labas. No? So we are inviting, no, if you are an electrical suppliers, baka pwede po tayo magtulungan, mga sir, no, ma-promote pa namin yung produkto nyo, no. So yun ang maganda. So i-discuss ko po yung inyong mga produkto at kayo din, bibigyan din namin kayo ng oras mag-discuss, no. Sa akin po, i-discuss natin yung theoretical side ng inyong produkto. No, kayo naman po yung, let's say, marketing side and other technical side, mag-discuss nyo yung inyong produkto at gagawin po natin siyang pre-webinar. No? Nakatulong pa tayo sa mga estudyante natin. Di ba? Biro mo, libre lang. Let's say you have halimbawa, meron kayong bagong technology dyan na mga produkto, electrical product. No? Ano bang halimbawa? Halimbawa, meron kayong generator na di kuryente. Bago ba yan? Nalala ko si Gagay. So, any electrical product. Let's say you have a lightning arrestor, no? You have a transformer, you have pumps, no? You may discuss here. You may discuss, no? So, pwede po natin pag-usapan ito at napakaganda po nitong opportunity na ito. Kahit paano ay may nagtiwala naman po sa atin na 13,000 at mahigit kalating milyon na rin po ang nag-use po sa atin. Malay nyo, makita po nila ang inyong mga produkto at mag-avail po sila sa inyo. So, pwede po natin pagtulungan ito mga kawerta. Ano po? So, if you are interested, email us at powerhouse_eereview@yahoo.com or send us a private message at our messenger account, the Marina is Powerhouse messenger account. Ayan po mga kawerpa. I should say, thanks be to God. Maraming salamat po sa inyong lahat mga kawerpa. At sana po may natutunan po kayo. Salamat po ng maraming salamat. Thanks be to God. Okay, sasend na po namin, no?